I'm going to show you how to get set up ready for the session. First, we're going to have to make sure you've got Python installed. The easiest way to get access to Python with a bunch of extra tools is by downloading the free tool Anaconda. So if you first go to anaconda.com, click on the download link up there in the top right hand corner. And on this page, if you scroll down the page, you'll end up on the download section where you've got a choice between Python 3.7 and Python 2.7. Make sure at this point you click on the Python 3.7 version, not Python 2.7. Click the download link and follow through the installer, and once you're all done, go ahead and launch Anaconda Navigator. Anaconda Navigator will look something like this. We'll be using JupyterLab in this session as it's easy to get started with, but if you have another setup using something like PyCharm, Visual Studio Code or Spider, that's absolutely fine. Feel free to go ahead and use those. On the JupyterLab tile, click on the launch button and it will open up a window in your web browser, which will hopefully look something like this. It might take a few moments to launch. Now I'm going to go through and show you how we're going to set things up in JupyterLab for this session. First, we're going to launch a text editor. So if we click on File in the top left, go to New and click on Text File. We can now close this launcher window because we don't need that anymore. Second, we're going to launch a terminal. So we go to File again, and once more New, and go down to Terminal and click that. Finally, we're going to launch a Python console. So if we click on File, New, and the top value there is Console. This should pop up a window asking you which kernel you want. If you're asked this, make sure you select Python 3. Now we're going to make sure we lay this session out so it's going to be easiest for us to use. I'm going to minimize this area on the left here just to make a bit more space on the screen, and I'm going to maximize this window. The way I like to have things laid out is with the text editor on one side of the screen and the areas where I run code on the other. So to do that, I'm going to click and hold on the tab of the console, and as you do that and move the mouse, you'll find that a blue box appears. If you move that to the right hand side of the screen and let go, you'll see it's laid out side by side. I do the same thing with the terminal. Click, drag, and hover so that it completely covers the console on the right hand side. When I let go, we have a console tab, a terminal tab, and a text editor on the left hand side. With that, you're ready to start. Welcome to Beginning Python. I'm going to give just a minute first to check that everyone's got Anaconda started up and have able to launch it and get it all working. So just take a minute now to start Anaconda Navigator, and if you can, also start JupyterLab. And in just a moment, I'll start going through that myself, and those who haven't got it set up themselves can hopefully follow along and be ready to get started. So the way to start Anaconda Navigator will depend on which operating system you're on. It varies from place to place, but hopefully the instructions that were provided with it gave you the ability to get at least as far as a window that looks something like this one here. So it's the green Anaconda Navigator with the circle and a bunch of tiles on the screen as well. Anaconda Navigator is the way that we are getting access to Python. So Python is provided for free. It is a completely free and open source piece of software. There are lots of ways to get it installed onto your system, but one of the easiest that we found, particularly for these training sessions, is the Anaconda system. So Anaconda provides us with the programming language Python, as well as a bunch of tools which we can use to write and run Python scripts. Some are basic tools and some are very advanced, and you see a selection of some of these on the screen here. For the course today, we are going to be using a tool called JupyterLab. Note that JupyterLab is different to Jupyter Notebook. JupyterLab is a web-based, simple development environment which allows us to write and run Python scripts and more, but that's the extent that we're going to be using it for today. So go ahead and press the launch button on the JupyterLab tile, and I'll do the same, and that should open up in a web browser the JupyterLab environment. It takes a few moments, you see, your web browser should pop up. It thinks about it quite hard, you get spinny things, and then we are here. And with that, I'm going to put Anaconda Navigator away, make this full screen, and nice and big. So you should end up in an environment something like this. If you've already followed through the video explaining how this stuff gets set up, then you'll automatically be left in the environment you last left it in. So it should all be laid out correctly. So the things we're going to be doing in the session today is writing Python scripts and running Python scripts. So there's two different tools that we are going to be using. Firstly, we're going to be using the text file environment to write our Python scripts. So I click on text file, and that has opened up this whole window here as a text file. It's just a text editor. I'm then going to open a terminal. To do that, I click in the plus in the top left, and then at the bottom here, I press terminal. I now have a terminal covering my screen. To make it easier to see everything that's going on at once, I'm going to click and drag on the terminal tab over to the right hand side so that I have the text editor on one side and the terminal on the other. This is all covered in the first video that we sent out, so if anything here isn't working or you've just missed what I did, feel free to have a look at that first video. It's only a few minutes long to catch yourself up. I'm just going to do something which you don't need to do, so ignore this. It's because I've got my files in a special place to avoid confusing things. There we go. So we're going to start off by writing our very first Python script. But before I jump ahead and do that, I'm just going to give you all 30 seconds or so to make sure you're up to speed with this. You've got your text file open, you've got your terminal open, and it looks largely the same as what you see on my screen. Bear in mind, anything you have in this bit on the right might look slightly different, but it's basically the same. Hopefully everyone has now got their environment set up like you see on the screen here. So we're going to go ahead and run our first Python script. So before we can run any Python code, we first need to write some code. So let's go over to the text editor on the left hand side. And the first thing we want to do, because currently this file is called untitled.txt, the first thing we want to do is rename this file so that it has the correct file extension. So Python file should end with .py, not .txt. And secondly, untitled is a undescriptive name for what we're going to be doing. So if you right click on the file name in the file browser on the left hand side and go down to rename, so right click and rename, and we're going to select all of that text including the .txt, and I'm going to call it script.py, and then press enter, and you'll see it's renamed here and it's renamed up here. You should also see that the little icon next to it has now changed into the logo of the Python programming language, so we know that it's understanding that this is a Python file. With that, we can go ahead and start writing our Python code. We're going to start with what is probably the simplest Python program you can write, and I'm going to explain the different components that go into it, and from there we're going to build up into more and more advanced scripts as we go through the session this afternoon. So the first thing we do is write the word print, all lowercase and without any spaces before or after the word, and we follow that with an opening and a closing round bracket. This is the print function. Functions in Python are usually lowercase, they can't have any spaces in the name of the function, and a function is called by following it with an opening and a closing round bracket. Some functions don't take any different parameters or arguments, so they don't have anything in between the round brackets. The print function, however, does take arguments, and the arguments it takes are things that we want to display onto the screen. So to give information into the print function, we have to put something in between those two round brackets. So what we're going to put inside there is some words. We're going to ask it to display some words onto the screen. The way that you represent words, or as they're known in Python, strings, is using pairs of double quotes. So if you do a double quote and another pair of double quotes, and then in between them we write hello. So what we have here is the word print, followed by an opening round bracket saying that we are calling the function. Then we have the thing that we're giving to the function, the information that we want the function to process, followed by a closing round bracket to say that we've finished giving information to the function. You'll notice here that the text has been coloured green and red and so on. The specific colours aren't really important, it's just the way that the text editor gives us a bit of information. So it's telling us that it's understanding what's been written. Other editors that you can use won't have this particular colours. They might use blue and red or blue and pink or any other colours in principle. The other thing to note is that the text here is just plain old text. There's nothing special about the program that we're running this in. We can write Python scripts in a basic text editor like Notepad, or you can use advanced integrated development environments like Visual Studio. All of them work in the same way. They're writing simple text files which are then going to be interpreted as Python code. So in order to run this script, first thing you need to do is make sure it's saved. So one way to do that, I think, is to go to File and Save Python File. Make sure you always save your scripts before you run them. Now that we've saved that file, we can go over to the terminal. So we're going to write our Python scripts on the left and run them on the right. To run your Python script, there's a few different ways you can run your Python script, and I went through the options for that in the second video that was linked and it's been posted in the chat. So if you get any errors coming up, go and check out that second video, and that will explain what the other methods are and what kind of error message you might see, and have a go at them. And if that doesn't work, let us know in the chat and we'll give you a hand. But the way I'm going to be doing it on my screen is by running the program Python. So I just write the word Python, ignore the $sign, that's just something that's built into my terminal. That's there by default, you see, that's just telling me that this is a terminal. I write the word Python, followed by a space, and then I give it the name of the script I want it to read, script.py. And so what's going to happen here is that this program here, which is called Python with a lowercase p, is going to read the file that I give it, which is this text file over here, and it is going to read that file one line at a time. It's going to look at the text on that line, it's going to interpret it, assuming that it's written in the language Python. Python is a language as well as a program. So as long as we've written some text in this file in the Python language, then the Python program is going to be able to understand it and do the things that we've asked it to. It's going to read it one line at a time and do the things on that line, then read the next line and do the things on that next line, and so on until it gets to the end of the file, at which point it will exit and say, I'm all done, success. So to tell it to actually kick off that process, in the terminal over here, after writing Python space script.py, we just press enter. And we see here it has done what we've asked it to. It has printed, this is a bit of computer jargon, print in computer jargon generally means display on the screen. It doesn't literally mean print it out of a printer. It's a holdover from the olden days of computing when everything was literally printed out on a printer. But it's displayed the text on the screen, hello, the same as we wrote in our file over here. It has then returned us back to the terminal prompt, the same as it was before, with a flashing cursor, ready for us to run the same thing again. So I'm just going to give you a minute or so now to have a go at doing that yourself. I'm also going to point you at the course notes. So what we're going through here, at the bottom of the first page as a next link, we're having a go at the chapter titled Getting Started here. On the whole, I'm going to be just doing the examples as they are in the notes, and I'll hopefully have Gareth keeping us topped up and tracked as to which chapter we're on. But here we are just going through this very first chapter titled Getting Started, in which we've written a text file and we've run that text file, and then a little bit of an explanation about how that all works, which I've just gone through. So have a go at that yourself, just take a minute or so, and if that's all working, then we're going to carry on in about 1 minute. That should be enough time. Mingdi, so the colour in the terminal doesn't matter at all. Mine is all multicoloured because I'm running ZSH on Linux, which has been set up to be all multicoloured. On most systems, it's just going to be plain black. So if you see hello printed out, then everything's working great. Some questions from Livia and Bryony saying you're getting syntax error, invalid syntax. That's, again, a number of different ways that this can be caused. There's two main types of errors that Python has. There's errors that happen while the program's running, like you've tried to divide by 0, or you're trying to use some information that it doesn't know is there. The other type of error is a syntax error. And that's when your file is written in something which isn't valid Python language. So the first thing to check is that your Python script looks exactly the same as it does over here. That you're using double quotes and not backticks or anything like that. That you're using round brackets and not square brackets or curly brackets. And that everything is in the same lowercase print as you see here. Do you get anything else printed out in the terminal apart from the syntax error? Could you copy and paste the entire thing of you running the script and the output in the chat, and that might help me work out what's going on there. Ah, okay. I see what's going on here. So this will happen if you've accidentally got yourself stuck in the Python interpreter. There's a thing that happens if you just type Python and press enter. So don't do this, I'm just demonstrating. If you do this, you end up in an environment where you've got these 3 arrows here. Now this is like a terminal, but it's slightly different. If you end up there, type exit and then open and close round bracket and press enter. And you should end up back at the non-3 arrow terminal. Once you're back at the normal terminal, you should be able to type Python script.py and you should get the text printed out. So I'm just going to clear my terminal on the screen there so that it has a bit more space. Don't worry about doing it yourself, just clearing out what we see. So in Python, there are a bunch of different types of data that you can have. The types of information we've used so far has only been one type of data. We have had a string. They're called strings because they're kind of like a string of letters chained together. It's another bit of jargon which you will get used to. So we have a string here. Hello is a string. Strings are designated by having open quotes at the beginning and open quotes at the end. But as well as strings, there are also different kinds of data types. I'm just going to run the script over here. As a shortcut and a tip, if you're in the terminal and you press the up key on the keyboard just once, it will bring up the previous command you ran. So you can press up on the keyboard and then press enter, and it will rerun that same previous script. I'm going to change this print function here now so that it prints something else. So instead of printing hello world, I'm going to print a number. So 3.14159, that's more than enough digits of pi. You'll see here that the number is green, where the string was red. That's just a decision that the highlighting in this text editor has decided. Again, the colours aren't particularly important. They're just there as a visual aid. You'll notice again there's a black circle here, and I'll point this out in the video, but make sure that before you run your script, you save the file. On Windows and Linux, it's Control-S, and on Mac, it's Command-S to save the file, or you can go to File, Save Python File. I'm going to use Control-S. So now if I run the script by pressing up and enter, we get our number printed out. Okay, so we've got strings, we've got numbers, and we also have integers, which don't have decimal places. That works very well. So if we save that and run that, we just get the number 3 getting printed out. So Sam in the chat is asking, why don't you need quotes for numbers? So the reason for that is Python uses syntax to work out what you're trying to tell it. There are fundamentally different types of data that you deal with in programs. There are words which as a human you interact with because you're trying to describe something to someone, like saying hello. And when Python is reading this, it will see the string and it will say, okay, I know that you're not, this stuff inside the quotes isn't special in any way. It's just something that a human would understand, and I don't need to worry about what's inside those quotes. If it sees just as it's reading along the line, you know, one letter, one letter, one letter, and it gets to here and it sees a number that's not inside quotes, it's going to treat it as that particular mathematical number. And it's important because something we're about to see in a moment, that mathematical numbers in Python you can do maths to. You can do 3 times 2 or 3 divided by 4, and that's going to give you another number. Whereas something like hello, it doesn't make sense to divide hello in quotes by 3 because there's no description of how you divide a string by a number. And so by being explicit from the beginning about what kind of data you're dealing with, it lets Python know what kind of operations can be done to it. A thing to be aware of is that the string 3 is different to the number 3. This one up here, Python will just see as some words which humans understand and it doesn't have to care about. This second one here, it will see as the mathematical number 3, which it can do something with. So anytime you're dealing with numbers in Python, generally you won't put any quotes around it because you want the mathematical concept to be the thing that you're talking about. That said, it is sometimes useful to be able to talk about the types of data you're dealing with in a more kind of abstract sense. So in that example there, we just had a print function and we were just throwing the thing that we wanted to be printed straight inside those double brackets, and it was reading whatever we passed in and it was printing out to the screen. It's quite common to want to give names to your data so that you can refer to it multiple times, or to work as an aid to the reader so they understand what's going on. So for example, 1.3.14, that's good enough. Here we have a Python script which doesn't do anything. It's simply a number. So this here is a piece of data. We can give data names by assigning what's called a variable. And the way that you assign a variable to a piece of data, or assign a name to a piece of data, is by writing the name of the variable you want to create, followed by an equal sign, followed by the piece of data. So this is going to make a new name pi, which contains the value 3.14. This means that later on in our script, we can write print, and instead of writing 3.14, we can go ahead and replace the number literal that we would have put there with the variable name pi. And so when print pi gets read by the Python interpreter, it's going to say, okay, here's some letters. They're not numbers, they're not in quotes, so this must be a variable name. It's going to look up what that variable name is. It's going to see that it's this value here, and so 3.14 is what is going to be printed. So if I save this file and run the script, we see that it prints out 3.14. From the outside, it's looking basically exactly the same, but inside, we've broken it up into two parts. The parts dealing with our data and the part dealing with our output. So take a minute or two now to have a go at that yourself. Take any print function you want to do, anything that you'd want to print, but break it up over 2 lines. One line which takes that thing that you want to print and gives it a name, and then another line which has a print function which accepts that name as an argument and check that it prints the correct thing to the screen. Be aware that variable names can't have spaces in, they can't start with a number, and there's a few other constraints which you might find as you go along. I've introduced variables. A variable is a way of giving a name to data. And so in your head, it's worth having a sense of the difference between a piece of data, like 3.14, and a variable like pi. They can often be used in the same context, but they're fundamentally different elements of the language. So it's worth kind of working out in your head as we're going through the exercise, thinking about how data and variable names differ from each other. We've always seen a few ways. For example, a string has quotes around it and a variable name doesn't, so they look different, but they also serve slightly different roles in the language. So hopefully as we go through, you'll start seeing how that works. So I'm going to delete all this text and start with something different. So let's make a variable called distance in miles. And you'll see here I've used underscores between the words. There's a convention in Python to write your variable names as lowercase, to use full words in your variable names, and anywhere where there would be a space to use an underscore. Other languages have other conventions, but this is the general convention in Python, and it's the one I'll be following. And let's give it a value 30. So here we just have a number 30, which has no context or no information about it. Because we've got context here in the name of the variable that it says distance in miles, that tells us what this 30 actually represents. And so it's useful when writing Python scripts to give your variables descriptive names, because it will help you understand what the numbers actually mean. If I want to make another variable called distance in kilometers, I could go ahead and just assign this a value. Now, I don't even know what that would be, but it'd probably be something like 50 or so. But of course, that is not using the computer to my advantage. I could Google it, find out what 30 miles in kilometers is, and write the value in here. But a more flexible and reusable approach is to work out what the conversion factor is, and to do that conversion ourselves in our code, so that we can change one variable and always have the other one automatically updated. And so when assigning a variable, on the right-hand side, you can do more than just write a piece of data. You can also refer to other variables. For example, distance in miles, and we can multiply that by a number. And I'm going to copy the number from down here to avoid errors. So here we made a new variable, and the value of this second variable is based on another one. So then when we print distance in kilometers, and then I save this file and clear it and run it, we see printed out it's 48.2. It's about 50, but it's a much more precise answer. This means that we can come back to our original script, and we can change this to be 5,000 miles, and we can find out what 5,000 miles is in kilometers just by changing one number, rerunning the script, and we find out that it's about 8,000 kilometers. So this is starting to show the value of using variables rather than hard coding your numbers. It's also showing you how you can use variables which are based on other variables. As well as multiplication, there are other mathematical things that we can do. So I'm just going to copy and paste this one from my notes down here. No one wants to sit here watching me type all day. And so here we have a variable which is a floating point number, a decimal place number on the right hand side. We're making a new number which is that plus something, and then we're printing that out. In Python there are 4 primary mathematical operations you can do. Plus, well, uses the plus sign. Minus uses the minus sign, as you would expect. For multiplication, it uses a star. And for division, you use a slash. So those are the 4 primary different types of operations that you can do to mathematical numbers in Python. Going back to Mendy's question earlier about why some things are in quotes and why some aren't, I'm going to show you an example now of how Python sees the differences between those two types of data in the program. So I'm going to make a variable here, and I'm just going to call it my underscore number, and I'm going to set it to 67. And I'm then going to say my other number equals my underscore number plus 100. And then I'm going to print my other number. So we run this script, we get the kilometer thing and the Celsius thing printed out, and we get 167 printed. So it's successfully printing out the thing that we had. If, however, we put this 67 in quotes, Python is no longer seeing my number as being an integer. It's no longer seeing it as being a mathematical object. It's seeing it as being a text type object. And it doesn't know how to do mathematical things to text objects. So if we now run our script, we will see the first of our Python errors. It is unable to do the addition operation because it's no longer doing it to 2 numbers. It's trying to add a bunch of letters and a number together. And it's going to say that it's assuming that you made a mistake. It's not going to just implicitly convert something. It's going to make sure that you're going to be explicit about what you're doing. And so we look at the error over here. The way that I read Python errors is by starting on the last line. It says type error. So that's telling it it's an error to do with data types, where types are things like strings or floats or integers. The error message itself is saying it can only concatenate strings and strings. Remember, this is a string, which means that my number is a string, which means that we're doing my number, which is a string, plus an integer. And so it's interpreting this as us trying to take one set of letters and stick another set of letters on the end. And that's what concatenating string to string would mean. Concatenate means stick next to each other. However, it's finding an integer, and so it's saying, I don't know how to do that, and so I'm going to bail out and stop. And when you get an error like this, the program will stop running, it will return you back to the terminal, and it will print an error like this on the screen so you can work out what's going on. So always start with the last line, because sometimes that's enough to let you know exactly what you did wrong and to let you know what's going on. If you've got a long program where your errors can crop up in all sorts of different places, it's worth looking at the lines above, which tell us where the error came from. This line here tells us which file we were on, which line we were on. We see it's on line 14. This is why programmers always have the line numbers turned on in their text editors. And then this line here in the output is the exact line that we had in our text file to give us context, to let our brain jump back to the error a little bit more quickly. So with that, I'm going to ask you to have a go now at the exercise at the bottom of the data types chapter. So there's an exercise there to edit script.py so that it's made up of adding two strings together. So originally it said hello Python. In fact, I'll show you how it looked beforehand. It had something like my words equals hello Python, and then it was print my words. It might have had a different variable name, but that is not important. So have a go at taking this little program here, but breaking up this line here into two separate variables, one which has the word hello in, one which had the word Python in. Make a third variable, which is those two things added together, and then print that out and make sure it looks how you expect. Once you've done that, carry on to the end of that data types chapter. There's a section there on printing multiple things. So have a go at that, reading through that, and having a go at that exercise as well. Mengdi there has a question about, is there a difference between my underscore words and my words with or without the underscore? So the first thing I would say to that question, Mengdi, is the best way to find things out is to try them for yourself. You'll often discover something really interesting if you have a go with something and it works or doesn't work how you expect. That said, I will go through that with everyone because I think it's an interesting thing to look at. So here we made a variable called my underscore words. If I delete that underscore and put a space and put a space here, and then we try and run this script, I'm going to clear this and run the script, we get a syntax error. And the reason we get a syntax error on that first line is because Python starts reading at the beginning of the line, it sees the word my, and that's a variable name by itself. So the only thing that's able to follow a variable name by itself at the beginning of a line is an equal sign. It only makes sense if you're immediately following it to assign this variable a value. Because it sees the space as a break between two different variables, it's expecting there to be an equal sign next and not a space and some words. So this is telling us, the fact that we get a syntax error here, that my space words doesn't get seen by Python as a single thing. It gets seen as two separate things, a thing called my and a thing called words. And because they don't make sense next to each other, it's not understanding what you're trying to say here. So we need to put an underscore in. Sorry, an underscore. If we try that again, we'll probably still get an error. We do, but this time the error is on this line here because the same thing's happening. As an argument to the print function, it's expecting a single variable name. Here we're giving it two variable names separated by a space. It doesn't know what that means, and so it's going to give us a syntax error. So we need to have underscores. We could do it without any underscores at all and no space. That would work perfectly fine as well. The underscores are just there for visual clarity. Okay, so I'm going to show the answer to that exercise you were just working on. Hopefully you had a chance now to have a go with it. So as I explained to Mengdi, underscores are used for visual clarity and you can't use spaces in place of them. So we have our string here. We are going to change it into word 1, which is going to be hello. It's going to be word 2, which is going to be Python. And then my words is now word 1 plus word 2. We save and run this. And we see hello Python printed to the screen. The last section on that page was taking this example and making your life easier. You'll notice that you had to put a space here because when you add strings together, it doesn't automatically put a space in for you. If we get rid of that space and run our script, we get hello Python, all one word, which is not usually what we want. So what we can do with the print function is get rid of this line entirely and simply print word 1, comma, word 2. The comma here is telling the print function that we're giving it 2 separate variable names. It will take one, it will print it, then it will do a space automatically, and then it will print the second argument. So if we save and run this, we get hello Python back again. With that, I'm going to move on to the next section. At the bottom of that page there, if we press next, and we go down to the bottom, we press next, we end up on a chapter called lists. So this is when we start getting a little bit more interesting with things. So far we've been dealing with single pieces of information, a single number or a single set of words, a single string. But quite often in real life, and therefore quite often in programming languages, you want to deal with something that contains multiple objects. The example I always come back to that I think most well represents real life is a shopping list. You go to the shops and you have a list of things written down on a piece of paper. You have one shopping list, but inside that list you have a set or a list of items that you want to buy. You can think of each item as a string, but we need in our language some way to describe the list as a whole. The way we do that in Python is with a thing called a list. A list is a built-in type in Python, and it's what's called a container. It contains other pieces of data. So I'm going to switch back over to my editor, and I'm going to make a new file. So I'm going to go to File, or not File, I'm going to click on the launcher, and put it here, and make another text file. So I've still got my old file here, but my new file here, I am going to rename it to list.py. So it's called list.py at the top, and then we can go ahead and close script.py. We don't need that one anymore. So I'm going to go ahead and make one of these containers. Like anything else, we start by giving it a name. You almost always want to give your variables names, and this is a really good way of making sure that you understand the kind of thing that's inside it. Same as before, we follow it with an equal sign because we want to give it some data. In the past, we would just write a number here, or a string, or do some kind of numerical work on some other data type. To make a list, we use square brackets. And I'll point this out at this point, that in Python, there are lots of different types of brackets used in different situations. It really matters which type of bracket you use. So far, we've used round brackets for calling functions. And here we're going to use square brackets to create a list. In between those square brackets, we put the things we want in our list. For example, cat, that's a string. We follow that item with a comma. Notice the comma's outside of the quotes. Dog, and let's put a number in as well, 261. So you see here we've got one list, one object that has 3 pieces of data inside it. Penguin, yeah, let's do a penguin as well. Thank you, Gareth. Penguin. You can have as many items as you want in a list. It's not limited to just 3 or 4. You can have lists with thousands of items if you so wish. You can also have lists with no items in. If we write it like that, that's a list with no items in. When we print our list, we can print it like any other variable. My_list. What's going on there? There we go. And we run it with Python list.py because our script is now called list.py. Run that and you see it's printed out the things that we put inside our list. It's got the square brackets printed out on the output to remind us that this is a list we're printing. It's got commas separating each item, and it's got quotes showing that these are strings. You'll notice that when you print it out, it uses single quotes, whereas when we made it, it had double quotes. That's because in Python, single quotes and double quotes are almost interchangeable with each other. There is a subtle difference between the two, but largely they mean the same thing. The convention is usually to use double quotes when making strings. However, regardless of what you make your string with, when it prints out, it will print with single quotes due to an older conventions. You know what conventions are like, they change every week. So have a go at that yourself. Make a list with some items inside it. Try putting some strings in there, some numbers, some floats, all sorts of different things. And make sure that you can print it out and it shows up on the screen correctly. Okay, so hopefully you've all managed to print a list out and that's all working for you. So we're going to move on and do something a bit more useful with a list than just making a block of a list and then taking that whole list and showing it to you on the screen. With a shopping list, you don't just deal with a shopping list on the whole, you deal with the items inside the shopping list. And so we need a way in our language to get access to the items inside. So we're going to make a new variable called myElement. Element is jargon generally for an item inside a list. Though the jargon isn't very consistent and you'll see it change later, but nonetheless it's often used for that. To get an item from inside a list, we write the name of the list and we follow it with square brackets. These square brackets that immediately follow the name of a variable are different conceptually to the square brackets we used when we made the list. If you've got square brackets by themselves with a space beforehand, that's you making a new list. If you've got square brackets and they immediately follow a variable name which is a list, that's you accessing things from the list. It's you asking a question of the list. We can put something inside those square brackets, kind of like a function call, to tell it what piece of information we want. So we can write, for example, number 1. And we want to not print the whole list, we want to just print that one element. So, audience participation time for those who are listening. Who wants to let me know in the chat what's going to get printed out when I run this script? And don't be shy. Okay, we've got some cats and some dogs. So those who are saying cat might be confused about how it could possibly be dog. Let's run it and find out what actually happens. We do indeed get dog. The reason for that is that in Python, everything starts counting from 0. When you're talking about elements in a list, the first element is actually the 0th element. This is item 0, this is item 1, this is item 2, and this is item 3. Everything in Python starts counting from 0, and it is very consistent with that, and so it's a thing that's worth remembering. If we change this to myList 0, at this point we should indeed get cat printed out. By that logic, if we want to get penguin for Gareth there, if we do it with number 3, we should get penguin printed out. Next pop quiz. What happens if I put in 7? What's going to get printed out here? Any guesses? Great, everyone's telling me that it's going to print an error. I expect by this point many of you are used to seeing errors because Python does throw them at you quite readily if it thinks you've done anything even slightly wrong. Over time you will learn to appreciate and love Python exceptions and errors, but when you're learning it can feel like you're being told off. The thing to remember is that it's just trying to tell you that it doesn't understand what you're telling it, and that it's thinking you might have made a mistake and it's trying to give you the information you need to fix it. Let's run this and find out. We do indeed get an error. Like before, we start reading at the bottom line. It is an index error. It's called an index because this operation with square brackets is sometimes called indexing. The actual text of the message here, list index out of range, is telling us that the list, my list, the index we're asking for, 7, is outside of the range of valid numbers. We only accept numbers from 0 to 3, so 7 is way out.
5 is right out.
And so it's going to give us an error. There's no valid answer we can give here. Notice that because it failed on line 3, which is here, the program stopped running. It didn't print an error and carry on. It stopped entirely. It never even tried to print my element. As soon as you get an error raised, the program just stops at that point and tells you what it knows about its state at that moment. So we know that 7 doesn't work, but 3 does. So far we've dealt with 0, 1, 2, 3, those all worked. We've tried bigger numbers, 4, 5, 6 and 7, those don't work. What do you think happens if I put in negative numbers? -1. Who wants to have a guess about what -1 is going to do? Costas thinks penguin, and you're not sure. Ricardo's guessing the same thing. Let's find out. Let's run it. We do indeed get penguin. We get the last element. So the designers of Python realized that all the positive numbers, including 0, if you count 0 as a positive number, are potentially valid inputs, depending on how big the list is. But you would never have any meaningful meaning applied to a negative index. It just doesn't make sense because we are counting. We aren't dealing with mathematical comparisons and so on. So they realized that because all the negative numbers are free to be used and they don't have any ambiguous meaning, you can use negative numbers for whatever you want. And they decided that -1 should mean the last item. And in fact, beyond that, negative numbers just count backwards along the list. So -2 will give us 261, -3 will give us dog, and -4 will give us cat. If we try and go to -5, we'll see that once again, we get an error. I'm just going to clear my screen up so that it doesn't disappear off the bottom. -5 gives us an error because indeed there's no negative things over here. It doesn't just loop round forever. It's bounded by the size of the array. The last thing I want to show you on this section, which comes to Rachel's question, and I'll come to your question in a moment, Rachel, once I've covered the basics of slicing, and that is, so far with indexing, we have simply selected individual numbers. We've asked for this element, or another element, or we've asked for something which doesn't exist by going off the beginning of the list or off the end of the list. It's quite common with lists or with any kind of container which has things in an order to want to grab a selection of items. So let's say we wanted to select items dog and 261. We can do that by using what's called a slice. It uses the same kind of syntax as we have here. So we still use the square brackets, but inside the square brackets we tell it where we want to start selecting from and where we want to end selecting from. So we want to select from here to here. So dog is item 2, and we want to go as far as, but not including, penguin. Dog is item 1, see, even I get mistakes. And we want to go as far as, but not including, penguin, which is item 3. The way I like to do the numbers here, because 1, 3 doesn't intuitively say to me those two items, is that I count the commas in the list as a way to remember what numbers I should put here. I imagine there's a 0th comma here, because 0 is invisible, so there's no comma. So this is comma 1, this is comma 2, and this is comma 3. So if I want to select from this comma to that comma, I do 1, 3, and that's going to give me this slice of the list. So when I print this, I get dog and 261. It's this subset of the list. Now, coming to Rachel's question, she asked, is there a way to get, say, the last 3 elements? Because if you do -3, -1, it will print the last 3 and 2 elements, but not the last element. Okay, so let's work up towards that question. So here we've got 1 and -3. If you remember earlier on, number 3 referred to penguin, but also number -1 referred to penguin. So we can replace that 3 with -1 and say we want to go from comma 1 to comma -1. A little bit confusing, I know, but the more you do it, the more you'll get used to it. So this is going to give us that same set of numbers. Likewise, this is comma -1, -2, and -3. We could change this to be -3, -1, and we print this, and we get the same bit of information. Now, Rachel was asking, how can we get it to include penguin as well? If we change this to a 0, that's not going to work. It's going to try and go from here to here. There's nothing to represent this comma at the end. It's going to try and go backwards. And in fact, if we try and do this, it will give us an empty list because we've tried to index backwards, and so it's just going to fail. If we want to go right to the end of the list, there's a special shorthand, and that is you just leave that space there blank. you say go from -3 to infinity effectively. And so when we run this, it's going to do dog, 261 and penguin. Likewise, if you do a blank at the beginning, it represents the beginning of the list. So just a colon by itself inside square brackets means right from the beginning until right at the end. So have a go at these exercises on this page here, the lists chapter. So get through as far as the slicing section if you can. The last thing I wanted to cover in this list section is how you can go about changing lists. So far the lists we've made have been static objects. They haven't had anything changing in them as we've been using them. But of course, lists are most useful if you can use them to collect information as you're going through your program, collect information in them, and then do something with that information at the end. So let's change our list here so it just contains animals. Let's delete this my element thing because we're not going to be grabbing something out of it. And let's print my list. This is now just going to print cat, dog, penguin. Let's pretend that what we're doing here is making a list of the animals that we have on our very strange farm. It's got cats and dogs and penguins. Maybe it's our pets. Maybe we've got a pet penguin. Maybe we're that lucky. In order to add something to a list, we write the name of the variable and follow it by a dot. After the dot, we write append. Append is a function, and so it takes brackets to call the function, just like print does. Inside those brackets, we pass an argument, which is the next thing that we want to add onto the list. Someone give me an example of an animal to add in here. Rat, there we go, wonderful. So when we run this, we will see we get cat, dog, penguin, and rat, all our pets. So what's going on here is we are referring to our list. This is the object, this is our data container that we have. By writing .append after it, we are calling a special kind of function, which is often called a method. That's just a bit of technical jargon, but they are relatively interchangeable terms, method or function, on our object. So the fact that it's a dot followed by the name of the function says that this function is going to be affecting this piece of data. And depending on what the append function does, it is going to take whatever's passed in and do that thing to my list. In this case, the append function takes whatever is at the end and takes whatever is passed in and adds it to the end of the list. Emma is asking, how do you add rat to be the second in my list? So there's two ways of interpreting that question, and I'll try and cover both of them. One is that maybe you are asking how you can overwrite the second item. So maybe you want to take what would be dog, second being number 1, remember, and you can assign that to be rat. This is going to take this list, then it's going to find my list 1, which is dog. It's going to overwrite it with rat. If we run that, we see that dog has become rat. If, however, you want to insert it into the list, this is where I can't remember everything. I believe there is an insert function. Let me just Google it, because that is how we learn. Python insert list. Since the Python 2 documentation, we want the Python 3 documentation. Here we have the list.insert function. It takes 2 arguments. The first argument is the position, and the second argument is the item. I can never remember which way round they go. So we want to insert at position 1, and we want to insert rat. So when we run this, we see cat, rat, dog, penguin. Hopefully one of those 2 things is what you are asking about, Emma. So hopefully everyone's okay with lists. We can loop over them, we can grab items out, we can change things to do with them by appending to the end, and as we saw there, overwriting or inserting. So after the list section, we are on loops. So hopefully as we go through this, Olivia, I will explain the answer to your question. And I'll just read it out now so that I remember what it said. At the beginning of the loop section, you assign two variables called word with different strings. So does the variable store all the data that you assign to it? Okay, so I will go through that now. I didn't realise how soon it was. So let's make a new file. And let's call it loop.py. New file, text file, rename, loop.py. So the example I start with is writing something like, we've got word, hello, we're coming back to our examples from the beginning here, and then we print word. We run that, print hello. Of course it does. We've done that several times so far. I think we're all comfortable with printing and variables now. If we want to print two things, we could do word equals Python and then print word. When we run this, it runs line 1 to assign a variable, runs line 3 to print out hello, then runs line 5 to assign a variable, and then it runs line 7 to print hello. Olivia's question there was we have assigned the variable word with the data hello, and then a few lines later we've assigned the same variable name with a different piece of information. What happens at this point in Python is that Python will forget anything about the history of the variable word. It will no longer know anything about the data hello. It will just know that word equals Python. Anything to do with hello from this point on in the program will be lost. It has no memory. It just remembers the most recent thing that you've done to it. The reason we get both hello and Python printed out is because we printed this one before we assigned the variable. This is one of the ways that variables in programming and variables in maths are different from each other. In maths, if you say something like a variable equals a number, you're stating some kind of mathematical fact that is then going to be always true for the rest of your analysis that you're doing. And so saying that word equals hello and then word equals Python doesn't make sense because it can't, a variable in maths can't have two different pieces of data associated with it. In programming, however, because we're going through sequentially, it does one and then it overwrites it with the second. The second thing that I hope you're all thinking about this little bit of code here is that it looks very repetitive. We've basically written two lines of code and then written exactly the same two lines of code with one tiny little change. Every time we see something being repeated like this in a program, we should always think there's got to be a better way. Programmers are lazy. The best programmers are very lazy because they make the computer do the work for them. So let's get rid of this. Let's make this a variable words, and let's make this into a list. So here, instead of two variables and printing one at a time, we've got one variable, which is a list which contains two pieces of data. And we're currently printing the variable word, which previously was referring to one word and then the other. But what we have here is a container, a list. What we conceptually want to do to this container is for each item in that list, we want to print that item to the screen. When you want to do something to each item in a list, we use a thing in Python called a loop, or in this case, it's called a for loop, because we are doing something for each item. And so we introduce that using the word for, and you'll see immediately it goes green and bold in our editor here, so we know that it's understanding what we're writing. I'm going to write it out and then I'm going to explain what these different parts mean. So the way I like to think about the structure of a for loop is first we just look at this line up here. This is the part that introduces the fact that we are going to be repeating ourselves. There's 5 different things in this line. 1, 2, 3, 4, and then the colon at the end, number 5. In every for loop you write, the for, the in, and the colon are always there, always in that order, and always spelt exactly like that. Those are the fixed scaffolding that we use to construct our repeating for loop. The places that we have flexibility and artistic license inside our for loop are in the other two locations, here and here. I'm going to start with the second of those, between the in and the colon. This is where we write the thing that we want to loop over. It is the thing that is the list that contains items that we want to do something to each item of. We want to do something to each item inside words, and so we are doing something for something in words. The thing we're looping over goes in this spot here. While we are repeating ourselves, while we are doing something to each item in this list, we need to give a name to the current item. We need some way to refer to it. Earlier on, we were referring to items inside a list using square brackets and numbers. But because here we're just going to be looping over the list, we don't care what number we're at. We are just going to be dealing with one item at a time as we're looping over the list. And so to make that work, we have to give each item as we come to it a name. We're only ever going to have one item in our hands at any one time. So only have to give one variable name. And the variable name we're going to use is word. It doesn't matter what you write here. You can give this variable any name you like. Like before, we had variables called mylist and distance in miles. In the same way, this is just a variable name we're creating. So the first time around the loop, this variable name word is going to be pointing at the first item in the list. Then the next time it loops around, this variable word is going to be referring to this item in the list. So the first time round, it's going to print word, so it's going to print hello. It is then going to repeat itself, and it's going to print Python. Let's check that that works. There we go. It prints out exactly the same thing as it did before, but what was previously 4 lines of code is now only 3 lines of code. Now that might seem like a small saving, but bear in mind that we could be looping over a list that had 1,000 items in which case this would still only be 3 lines of code. Whereas if we were having to print each item individually, it would be thousands of lines of code, and that is a lot of writing. The final thing I want to point out about loops, is that the colon at the end of the line in Python always designates that the next section of code should be indented. And that is why we have these spaces at the beginning of the line here. Python uses the fact that this is indented to know that these are the lines we want to repeat. If we write print ... no, in quotes, there we go. It is going to repeat, it's going to print this line and then this line, then repeat itself and do those 2 lines again. So if we run this, we see we get ... hello, ... Python. Likewise, we can print end, and it will do ... hello end ... Python end. I'll just clear that. If we don't want this end to be repeated, all we have to do is unindent it, which you do by pressing backspace. Because this is no longer indented, this line of code will not be repeated. So when we run this, we get ... hello, and then ... Python. Then because the loop's finished, because words has run out of words, it then exits the loop, unindents, and then runs this line of code just once. So have a go at the exercises on the loops chapter. Do the first exercise on there first, and then if you've got time, move on to the exercise at the bottom of the page. Don't go quite as far as enumerating, because I'll be covering that in just a moment. There's a question there from Sam. We use 0 and 1 in last exercise. Why can't you do that again? So you're saying, why can't we do print words 0? I'm going to delete those. And print words 1. There's no reason why you can't do that. And if we look, we'll see that those 2 things come out exactly the same. But if we have hi, it's Matt here, then we'd have to do 0, 1, and do a 2, and then a 3, and then a 4, and that's probably not even the right number. Hi, it's Matt, and I did miscount it, so they have to do a 5, and so then it's done the right thing. Hi, it's Matt here, but we've had to copy and paste, we have to repeat ourselves. It's very easy to accidentally do that and not notice that you've got a number repeated. Also, if you've got lots of items, you have to do lots of lines of code. This will always just be those 2 lines of code, regardless of how many items you have in the list. It's quite common with lists that as you're collecting your data, you don't know whether you have 99 or 101 items. You just know that you have a container with information in, and you want to do something to each of those numbers. Maybe you want to double them, maybe you want to print them, maybe you want to email everyone that's in that list because it's a list of email addresses. You don't care about where each item is, you just care that there's a whole bunch in there. So yes, it certainly is possible, but looping gives us the flexibility that we wouldn't otherwise have. Kunal asks, what if we want to print each item twice? Let's have a look. I'm going to simplify this back to where we were. So here we do this and it prints each item once. If we want to print it twice, we can just write print word twice inside it. If you want to do it 3 times, well, we could copy and paste it again. But as you can see, we're probably starting to get the point where we're repeating ourselves quite a lot. So as Gareth says in the chat, you can actually make a loop inside your loop. You could do another for repeat in. And the way that you repeat things a certain number of times is by using the range function, range 3, print word. And here, when we run this, we get it happening 3 times and 3 times. So then if we want to do it 100 times, we could just change that to 100. And it would print each word 100 times. Yes, so range is a special word. Or rather, it's a built-in function. In the same way that print is a built-in function, range is a built-in function. The job of the print function is to take the argument and display it on the screen. The job of the range function is to take the argument and to give us back a list containing that many numbers. Ronald, I'm glad you asked, because that's exactly the next little section, which I'm going to cover now, and then we're going to have a little break for a bit because we've been at this for nearly an hour and a half. So let's have a look at how to answer Ronald's question. So they're asking, what's a concise way for accessing the current index / iteration inside the loop? So here we are looping over for word in words. The thing that we're looping over is this list. And when you loop over a list, the thing you get given each time is each item in order. If you want to get each item and its position, there's another function called enumerate, which means give numbers to, which when we run it, we get back the index and the item. It gets given this back to us in this form with the brackets and the commas and stuff, which is useful, but it means that we can't access those 2 pieces of information separately from each other. So if we want to get access to the 2 things individually, we can take the fact that enumerate is giving us back a pair of things each time. And so instead of having 1 variable name here, we can have 2 variables separated by commas, where I is going to be assigned the first thing that's given back, 0 the first time, and word is going to be assigned the second thing that's given back, hello. So then now if we print item I is word, it'll print item 0 is hello, item 1 is Python. Kunal's question. So that's a question about documentation. How do I find suitable function for my tasks? There can be 100 built-in functions which I don't know about. So let's go to docs.python.org, exactly as Gareth's linked there. So the page that I was on before was a page called built-in functions. So you can go to the search, built-in functions, and then you can never find them. So what happens here is I go to Google and I search for Python built-ins, which is almost certainly what Gareth did. And there's a link here to built-in functions. And we have here a list of all the built-in functions, which include print and enumerate and range. And that gives you information about what's going on there. In general, the Python documentation will have information about every single thing you can do with Python the language. It's not always easy to navigate through here. So on the whole, the way I get there is by Googling for Python followed by the thing I want to search for. Like Python insert into list is what I searched for earlier. That will take me to the Python documentation. I end up in the right place. The thing to make sure you're doing on the Python documentation page is the link, there's a drop-down menu with different versions. Make sure you're not on the Python 2.7 page. You'll be able to recognize it because the 2.7 documentation is all blue and it's got a big banner at the top. So in that situation, click on the link here and click on the latest number up at the top. And that will take you to the current version's documentation. Ronald asking a question, do you take a bigger performance hit if enumerating a long list versus just adding a counter inside the for loop? So no, the way that enumerate works is that it only generates the indices as it needs them. It doesn't generate a big list in advance, it just keeps track along the way. So it's doing that counter inside the for loop thing for you automatically, which means you don't need to worry about setting it to 0 before the loop and anything like that. It just does all that stuff automatically. So there's no performance hit at all. It does it all dynamically on the fly. That said, if you're worrying about performance with a really, really long Python list, you're probably at the point where you want to start looking at more advanced Python tools. So there's a set of tools called numerical Python, sometimes abbreviated to NumPy or NumPy, that will have the tools in there for doing that kind of stuff nice and efficiently. And also in our Python Introduction to Data Analysis course, which Gary was just asking about, we go through a package called Pandas, which provides tools for doing this stuff nice and efficiently as well. So once you're at the point of worrying about performance, it's worth looking outside the built-in Python lists at what other tools are out there. Ronald, your question, is it possible to have local dummy variables inside a loop? Yes, it absolutely is. So I'll just demonstrate that quickly here. Let's make a variable called my number equals 42, and then let's just print my number. And when we run that, we see it prints the thing out and it prints out the variable as well. So you can introduce variables inside the loop and then they just sort of live inside that scope. So before the break, we were covering loops. That's how we perform the same operation multiple times. So to look at the example we have up here, here we were doing this line of code, which we've only written once, but it's going to be performed multiple times. So you write a line of code once and it runs many times. The other kind of thing you want to do to your code sometimes is to write a line of code which may or may not be run at all, depending on the context and the situation around it. The way we do that in Python is by using what's called a conditional. So let's make a new file and let's call it if.py because that is the question that we are asking. If. Let's make a variable. That's how we start almost all of our scripts. Number equals 128. Nice computery number. The way we ask questions of our data in Python is by using the if keyword. This works similarly to the for loop keyword that we had before. And you'll see it's done the same thing where it's gone green and it's bolded up as well. After the if, we are going to write something here, followed by a colon. Similar to the for loop where we had our scaffolding of the for, here we have the word if, and we have a colon at the end of the line. The question that we ask can be a whole bunch of different things. So I'm going to give an example and then I'm going to let you have a go at running that yourself. And then I'm going to be building it up bit by bit. One of the simplest questions you can ask is to compare the size of numbers. So let's say, is my number greater than 100? So this bit here is whatever we want it to be, as long as it's giving back something which is true or false. This means greater than. And if you have something on the left and the right that are numbers, it will compare them and give us back true or false, depending on whether they are bigger or not. If this thing returns true, if my number is bigger than 100, then it will run whatever code is indented in the block below, which in this case is going to be our trusty print statement. My number is large. So if my number is bigger than 100, it will run this line. If my number is smaller than 100, it won't run that line at all. Oh, no, that's not what I meant to do. That's what I meant to do. Python if.py. 128 is large. Copy that code into your own script, into a file called if.py. Do the same things I just did there and make sure it prints out the same output. Then try changing my number to be different things. Negative numbers, numbers that are near to 100, numbers that are small, numbers that are much bigger than 100. See what you get, have a little play, and make sure you understand what answers it's giving you back. So I had a go here and I set my number to be 999, and it likewise printed 999 is large. But if we make this smaller than 100, like 50, and we run it, nothing gets printed out. It just does nothing at all. So if we wanted to print out something if our number is less than 100, we need to use a different operation. Instead of saying, is it greater than 100? Let's change this to be less than, and let's say, is it small? So now when we run this, it says 50 is small. As well as, I'm just going to do some stuff down here. So greater than means greater than. This means less than. Greater than sign followed by an equal sign means greater than or equal. Hopefully you can guess that that means greater than or, no, sorry, doesn't mean that at all. It means less than or equal. If you want to check whether two numbers are exactly the same as each other, you use two equal signs next to each other. If you use a single equal sign, it will give you an error. If you want to compare numbers, you use two equal signs. Are they equal? And if you want to check that they are not equal, you can use exclamation mark equal sign. Are not equal. Are they? Let's be grammatical. So have a go now at tweaking your if statement to use a different sign. Update the little comment so that it does something, that it prints something that makes sense. Just have a little play with a few different operators, as they're called there, and see and check that they make sense to you, and then we'll be moving on to the next little section. If everyone's happy with that, everyone's had a chance to play around with different signs and check that it all works for them, then I'll move on to the next little section. I'm going to delete that because it's not valid Python code and it will give us a big old syntax error if we try and run it. It was just a comment. So a question you might have thought of is, I wanted to do one thing when it's greater than 100, and we say it's large. And then if we wanted to print something when it's smaller than 100, we had to delete the code and change it and make it say something else. What we'd usually want to do is to do one line of code if this condition passes, or a separate line of code only in the situation where that line of code doesn't pass. And we can do that using a statement called an else. An else statement in Python always has to follow an if. By that I mean you can have an if statement with no else, but you can't have an else with no if. So you just write else and a colon, and here we write print my number, if I could spell, is small. And so now we can run if.py, and it says 50 is small. We can say 990 is large. If we do 100 exactly, it tells us that 100 is small, because 100 is not greater than 100, it is equal to 100. Okay, so Olivia has a question about the indentation here. So the indentation here gets interesting. There is a consistency across Python with how indentation is treated, so it's worth taking some time to understand what's going on. The way the indentation gets applied is any line that's indented is always associated with a colon before, and that colon and the indentation associates this block of code with this statement here. So we could print hello as well. So these two lines of code are indented, so they're associated with the if parsing. This block of code is indented after following this colon, and so it's associated with this else. The if and the else are at the same indentation level because the else kind of sits next to the if, it's not inside it. And as I introduce the next statement here, you'll hopefully see why we don't keep on indenting, because you'll see that things get a bit messy. Because we might want to here do one thing if it's greater than 100, another thing if it's less than 100, but a third thing if it's exactly equal to 100. And for that, there's a thing called an else if. So here we say, if this thing's true, do this thing. Otherwise, if this thing's true, which let's make this my number is equal to 100, print my number is 100. And if that one's not true either, then it finally goes to the else. The reason you want to do that, and let's just check that works. Here we say, oh, we've got a syntax error. Of course, that was for demonstration purposes. In Python, you don't write else if, you write elif. It's an abbreviation they introduced for whatever reason. Here it says 100 is 100 because it's taken this number, my number. It's not larger than 100. It is equal to 100, and so it's printed this, and then it stops checking. When you're going through a chain of ifs, elifs, and elses, it will check from top to bottom. The first one that matches will run that block of code, and then it will drop out and not check anymore. And the reason you don't want to keep on indenting these things is because you can have as many elifs as you want. You can obviously have 0, because we saw that already. But you could also have a second one which checks if it's 42. So 100 is 100. 42 is 42. And 13 is small. If each of these times we had to indent our code, we would end up disappearing off the right-hand side of the page by the time we checked all our different conditions. And that is why we don't have to indent each block as we get to it. So for the exercise here, I want you to take this block of code, or a similar block of code if you've got different elses and ifs, and put it all inside a loop. Remember before I showed that you can nest loops inside of other loops? You can also nest if statements inside of loops, and vice versa. So take these lines of code, nest them inside a loop, and loop over a list of numbers, and check each of those numbers in turn and print out whether they're large or small or whatever else you want to check up on. I'm going to do it alongside you all on the screen here so that you can see how it works, and then I'll check back with you in a few minutes, and then we'll be ready to move on to the next section. So this is the exercise at the bottom of the conditionals chapter. Okay, so we've got one person's finished now. I'm going to go through the exercise answer with you all now to explain how it's done so we can move on to the next section. But with any of this stuff, I'll give you information at the end to do on how to get in contact with us afterwards. But we've got a quick question here from Olivia, asking about the difference between the numbers and range. So in my example here, I want to loop over the numbers 0 to 9, and so I've used the range function to give us access to them. The other way we could have done that is by doing 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Both of those are going to give us basically exactly the same answer, with the difference being that we've had to type a whole lot more for doing it explicitly. Secondly, if we wanted to loop over the numbers 0 to 10,000, it would grind our fingers to the bone having to type it all out. Whereas doing it using range, we just do that, and it's immediately going to give us access to them all. So that's one of the reasons to use range instead. But we start off with my numbers equals range 10, which as we saw before, give us the numbers from 0 up to 10, but not including 10. So that gives us the numbers 0 to 9. The if statements inside here are exactly the same type of thing as we were doing before. Is a number bigger than 5? Is it less than 5? Or is it neither of the two, in which case, well, it must be equal to 5, mathematically. The thing that we have done extra here is that we have indented all of this, as you can see. And we've done that because it is now inside a for loop. We are now going to be repeating this set of if statements multiple times. We are going to be doing it once for each of the items in my numbers, which is the numbers 0 to 9. Each time around that loop, we are going to have the variable num. So inside each loop, the variable num is going to be referring to first the number 0, then 1, then 2, then 3, etc., etc. And so it's that number which we are comparing in each of these situations and printing out. So when we run this code, we get, first of all, we get the first item from range 10, which is 0, which goes into the variable num, which gets compared to this. It is not greater than 5, so it goes to this one. It is less than 5, and so it prints out less than 5. It does the same thing for the rest of them until it gets to number 5, at which point it's not greater than, it's not less than, and so it does this block. Then it carries on through, and then all of the rest of the numbers are matched by the first block there. So this is to show that you can put if statements inside for loops, and it all just kind of works how you expect. In this block here, you can put some blank lines in here. You can look at this block of code, and even outside of the context of you knowing that you're inside a loop, this section of code still makes sense in itself, as long as you trust that there's a variable called num that you have access to. It doesn't matter to these lines of code that they're inside a loop. They are just doing the same if, else, elif, and else thing that they always do. In our case, however, we do want to make it clear that it's inside a loop because that's how we know that we're looping over the numbers. You'll use if statements a lot in your code. I find it quite uncommon to use elif. It's a corner case catching tool rather than everyday tool, but certainly I use a lot of if statements. I use a decent amount of else's, and I always use loads of for loops in my code. That is one of the most common things that I do in my code, is looping over stuff and repeating myself for each item inside a list. And Kunal asked, there are a lot of variations of if in Python, right? Yes, there's ifs and elifs and else's, and there's lots of different things you can put here. It gets quite complex to allow you to explain to the computer all of the different things that you might want to do. So I'm going to move on to the next section now. So after the loop section, I'm behind on the notes on the screen here, and after the conditional section, we move on to dictionaries. I'm going to make a new text file again. It's always good to make a new text file for each section of code that you're writing. And I'm going to call this one dict.py. Dict is the usual abbreviation for dictionaries in Python, and you'll see that cropping up a lot. So get used to dict meaning dictionary. And now I'm going to explain what a dictionary is. So a dictionary is similar to a list. Lists were containers which held multiple pieces of data. They held them in a certain order, and we could access them either by looping over the list or by asking for specific items in the square brackets, asking for item 3 or 0 or -2. A dictionary works in a similar way. It's a container which holds multiple pieces of data, but rather than holding them simply linearly all in a line and giving each of them a number to refer to it, we instead give each item in our dictionary a name or a key which we use to access it. You can think of it a bit like a physical dictionary where you have a bunch of words and their definitions. You look up the definition of a word by finding the word in there, and then the definition is associated with it. Let's look at an example now to see how it looks in code. So I'm going to make a dictionary which contains animal sounds, continuing our animal theme from earlier. So I'm going to make a dictionary called sounds, and inside this I'm going to make a dictionary. A dictionary is made using curly brackets. Now those are different to the square brackets and they're different to the round brackets. Curly brackets in Python almost always mean I am making a dictionary, in the same way that square brackets by themselves meant I am making a list. So once again, inside the curly brackets, that's where we put our contents of our list. Each item in a dictionary is a pair of items in this case. So we have here cat and meow. Those two things together, separated by a colon, are a single item in the dictionary because each item in the dictionary is a key and the value. We can add multiple here, for example, dog and woof. Sorry, that should be a colon. So here we have one item, which is this pair of things, and another item, which is this pair of things. Each item in a dictionary is made up of two parts, the key, which goes before the colon, and the value, which goes after it. I tend to, when I write dictionaries out, spread them over multiple lines because I find it a little bit easier to read. When you've got this many symbols hanging around, it can get a bit messy to the eye. So one thing you can do with dictionaries, and in fact with many things in Python, is spread them over multiple lines. So I'm going to put a new line in there, a new line after that comma, and a new line before that closing bracket. So this is exactly the same thing, it works in the same way, but it makes the fact that this item and this item are separate a bit clearer. Oh, sorry. So I'm going to ask in the chat, I need more than 2 items for my list because 2 is a bit boring. What other animals and sounds shall I put in here? We had penguin earlier on. What sound does a penguin make? Because I don't know. Gareth? Apparently they go meep. And we also had fox. There we go. Thanks, Maddie. Now what does the fox say? Screech. That sounds about right. I had one in the garden the other day and it made a very horrible noise. And we've got a duck. Duck. Going honk. And we have a sheep. And what noise does sheep make? Bah. Lots of A's. There we go. So, once we've got our dictionary full of items, each of these is an item, we have a key and a value associated with each. We get things out of the dictionary in the same way that we did with lists. So we're going to make a new variable cat sound, and we want to get from this dictionary the sound of a cat. So we go to sounds, we use square brackets, but this time inside the square brackets we don't write the number of the position of where the thing we're looking for is. We put in the square brackets the key of the item we're looking up, for example, penguin, and it will give us back the associated value, which in this case would be meep. So if you put cat in there, it's going to give us back, hopefully, meow. Let's print it and check. Cat sound. Oh, no, wrong file. Python dict.py. Invalid syntax. I've missed a comma there. Very easy to do. Cat sound. I made a typo. Till it's getting late when I'm making that many typos. It prints out meow. It's looked up the key we put in. It looks up in here. It's given us meow. If we change this to be just sound, because we're going to be tweaking what animal this is, change it to fox and print that, it makes a screech noise. So have a go at that yourself. Copy in that dictionary, try grabbing items out of it, and also see what happens if you ask for an item from a dictionary that isn't in there. For example, if you make a typo here, or you ask for an animal which isn't in there at all. Olivia asks, do you have to have a comma after the last key in the dictionary? No, you don't. That works just as well. The reason I tend to put a comma after the last item when each is on its own line is because when I add a new item, I only have to worry about this line here. I don't have to remember, add a new item like fish, bubble, and then, oh, I missed the comma there, which is exactly what I did wrong earlier. So I tend to always put a comma at the end of the line to avoid me making that mistake. Also, when you come to use version control like Git later on, it makes your differences between files a little bit neater to read if you have a comma at the end of each line. But largely it's a matter of style. I will sometimes use one or the other. Gary is asking, why does the dictionary use square brackets to search the items, not curly brackets? So this is where it gets a bit confusing with Python and the different kinds of brackets. Or at least it does seem confusing at first, but I'll try and explain the logic behind it. So the reason that we use different types of brackets for creating the different types of objects is to make it unambiguous when Python is reading the file what kind of object we're trying to create. And that is why right from the start you have to choose when creating something whether it's going to be square brackets to be a list, curly brackets to be a dictionary, or there are other types of brackets which get used as well. As for accessing stuff from lists, it's not ambiguous what we're asking for with the square brackets here, because each type of object can only be searched in one way. So if this were a list, then Python knows that square brackets is asking for it by number. This is a dictionary here, so Python knows that square brackets is asking for an item from it by its key. That allows Python to always use square brackets to mean give me something out of this list. And the syntax would always look the same, so you can look at the line like this and you don't really care whether sounds is a list or a dictionary or some other exotic type of data. All you care about as the reader of the code is that we know this is something which must contain stuff because we're asking for something from inside it, and we trust that the thing, in this case sounds, knows how to interpret it. The other reason is because there are lots and lots of different kinds of containers, beyond lists and dictionaries, which have their own syntax here. In more advanced Python tools, there are other tools which don't have their own individual way of creating with special brackets, but they are accessible using square brackets. And so by allowing square brackets to be the generic syntax for give me something from inside this thing, it makes the language nice and extensible. Now I'm going to move on to the next little section. Like we did with lists, we created our list statically, we've created our dictionary statically, it's fixed in the file. With lists, we could add items into it by using append, and we also saw the insert function when I was answering someone's question. Dictionaries have a similar ability. So I'm going to get rid of sounds fox. If we want to add a new item into a dictionary, we do it just by accessing it. So can someone in the chat give me another animal and a sound? Tiger. And what sound do tigers make? Grr. Okay, cool. That's scary. So you do it by accessing the item as if you're trying to get it out. But if it's not in there, because we've given it a value on the right hand side, it's going to insert that into it. And that means we can now do sound equals sounds tiger, and this will print out grr. Ronald is asking, can you modify the name of the key without changing the value? So we can change the contents of a value by doing this same thing. We could have put, for example, duck there and maybe make this a scary duck. But if you want to change a key, it's a little bit trickier. So you would have to, for example, let's say we've called this, let's say we made a typo, we called Tigger by accident. We would have to make a new one, sounds tiger equals sounds Tigger. And then we'd have to delete sounds Tigger. So it's a two-step process. So we put in an incorrect name there. We've then renamed it, and we can access it by the correct name, and that should work. So have a go at that yourself. Try adding in a new entry into the dictionary. Make sure it makes sense when you're doing it. Try overwriting existing variables, and I'll come back in a minute or so to move on to the next section. I'm going to cover the last section on dictionaries here before we move on to the last chapter in the course today. We're doing well for time, I think. And it's following the same kind of pattern to what we did with lists. With lists, we looked at making them statically, getting items out of them, changing items inside them, and then we moved on to looping over them. And when we loop over a list, we repeat each line inside the loop body once for each item in the list, and it works in a very similar way with dictionaries. So let's put tiger inside here because I don't want to leave any animals behind. So when we loop over a dictionary, let's find out what happens. The nice thing about Python looping and for loops is that they are very, very generic tools. You can loop over lots and lots of different types of things in Python, while the syntax you use basically stays the same. It doesn't matter whether you're looping over a list, or a string, or a dictionary, or as you'll see in the next section, a file. The words that you write on the page look very similar, and it's a general way of repeating yourselves depending on the kind of container that you want to loop over. So here we want to some kind of thing in sounds. And I'm saying thing because when we looped over a list, it was unambiguous what we'd get back. We had one item at a time. Here we've got two different things. We've got a key and a value, or potentially the whole thing all at once. And let's pretend we don't yet know which of those we are going to get back. And let's print thing and find out what thing is. So when we've looped over this dictionary, we've said we want to have whatever it is that looping over it gives us, and Python's decided that for us. And it looks like, looking at the output, that when we loop over a dictionary, we get back the keys from that dictionary. Cat, dog, penguin, fox, duck, sheep, fish, tiger. Those are the keys in our dictionary. It hasn't given us access to the values. So we now know that this isn't thing, this is a key. Again, the variable name doesn't matter, but it's good to use one that's descriptive. But better than that, actually our key isn't just a key, it's an animal. And suddenly this loop here is starting to read a little bit more like a human would understand it. For each animal in our sounds dictionary, print out the name of the animal. And that's what we get over here. If we want to get access to the values, there is a thing we can do where, like with the append function to a list, we do a dot values after the thing we're looping over, and that's going to give us back each of the values. So we now change this to sound and sound. Now it's giving us back each of the values one at a time. If you want to explicitly loop over the keys from the dictionary, like we had before, we can do that too by writing keys there and changing this back to animal. So if you have sounds by itself, it gives you back the keys. If you do keys explicitly, it gives you back exactly the same thing. Sometimes it's good to do it this way because it reminds you that it's giving you back the keys. The final thing that you sometimes want to do with dictionaries is not get back a list of just the keys or just the values. Sometimes you want to get back both of the things at once as a pair. Because as you can see in the output over here, the keys and the values have been disassociated from each other. There's no way to know which sound and which animal are related to each other. In order to get them coming out in pairs, there is a third thing that we can pass in here called items. Remember I said earlier that an item in a dictionary is this pair here, or this pair here, or this pair here? That terminology carries across to this function here. So when we ask for the items, it's going to give us back cat, meow, etc., etc. So let's have a look and let's call this thing again. And when we print this, we see it gives us back these pairs. Now these pairs work in a very similar way, well in fact exactly the same way, as we saw with enumerate earlier. With enumerate, we solve the problem of it printing out it with the brackets and the quotes by putting two variable names in here. And we can do the same thing with items. So we can write, for example, for animal, because the first thing we're getting back here is the animal, comma, sound. And then our print statement, we can say animal goes sound. And when we run this, it writes cat goes meow, dog goes woof, etc, etc. This is a very common thing I do, to be able to loop through a dictionary and get access to everything. But each iteration of the loop, I'm only being given access to one of the items, so the key and the value at a time. But that's really useful to allow me to go through and do something to each of the things inside the dictionary. Some questions in the chat there. So Rosalia is asking, my list is printing in a different order. Is that an issue? No, it's not. So until Python 3 point something, 3.4 or 3.5, the order of a dictionary wasn't preserved. So the order you wrote it here could easily end up being different to the order it's printed out at the end. As of a recent version of Python, they've changed it so that it's always preserving the order. But in general, it's good to not rely on the order of a dictionary. Treat it as a bag you've thrown a bunch of items into, and each time you loop over it, you stick your hand in and grab them in a random order. Assume that's the case, even if they end up coming out in the order you put them in. That's the safest way. And Amanda asks, can I assign more than one value to a key? You can. So let's look at dog. So here we've got dog making a woof noise. If we wanted to assign a list of values to it, we could say woof and bark. And so now when we print it out, we get dog goes woof bark. Of course, this isn't a very nice way of printing it. So we might want to have an if statement in here, which has something like if animal is equal to dog, animal goes sound 0 and sound 1. Make that a little bit bigger. So here we have assigned dog to have two values, and so when looping over it, we check if we're on dog. If we are, then we print both of the sounds. Otherwise, we print the one sound. And we look at that, and we see dog goes woof and bark, and the rest are just carrying on. So here we're combining together dictionaries, loops, and if statements all together. So have a go at running those things yourself, looping over items, keys, and values. Check you're happy with it, and then I'm going to be moving on to the final section in the course today, and that is reading files. Just take a few minutes there, and then I will be moving on. Salim, yes, the something going something is a strange Englishism which is a bit weird to translate. So we could instead write animal makes this noise. And then it says penguin makes this noise, meep. Fox makes this noise, screech. If that's easier for you to read or something, then go ahead and change it to that, and that might make it a little bit easier to understand what's going on. Emma asks, can you make the code detect that the dog has two sounds? Yes, we can. There's a few ways we can do it. I'm going to try and not use a way that's too confusing for new learners of Python. But we could, for example, do if there's a thing you can do called isInstance in Python, which checks what kind of data something is. And we could say if isInstance sound list. Let's see if this works. It then does the correct thing for dog. So this is saying if sound is an instance of the list type, then do this. Otherwise, just print it out on the screen. That's one way to do it. There is, in general, lots of ways to do things in most programming languages, and part of the job is working out which one's right today. The last thing I want to cover here in the dictionary section is right at the bottom of the dictionaries chapter. There's a little list of things that you can loop over. And I just want to draw your attention to that because we're going to be building on this in the next section. But to reiterate, when you have a for loop, the thing that you put in this section, between the in and the colon can be a list, or a string, or an enumerate function, or we saw range earlier, which isn't listed here, or dictionaries, or the keys of dictionaries, or the values of dictionaries, or the items in dictionaries. All of those things are possible, all with exactly the same syntax on this line here. The only thing you change is what you're looping over. Python has a very extensible and generic way of looping over things. So much so that we can loop over objects that aren't even part of the language itself. For example, files. So the last section we're going to do today is this last chapter here, files. So I'm going to make a new file, text file. I'm going to call it, maybe confusingly, file.py. And in here I'm going to also make a file. I'm going to make a second file, which I'm going to move down here, and I'm going to call this data.txt. And inside here I'm just going to write some, this is a file. So I made two files here, a Python file and a text file. And what we're going to do is write a program which can read this text file and display it on the screen. So the way we start this is by writing open, and then the name of the file that we want to open. The file by default has to be in the directory that you're running your code from. In this case, it's data.txt. In order to handle the file being automatically opened and closed, we need to introduce a new thing called it's called a context manager, but they're sometimes called with statements. And that's because it starts with and then has as f. And what this is saying is open this file, make a new variable called f, which is going to be referring to this file. It's our handle, which we're going to use to, hold on to refer to this file. And the with part is saying, because we've got the colon here, everything inside the next block is dealing with it while the file is open. And as soon as we finish and unindent, the file will be automatically closed. The reason to keep track of whether files are open or closed is because A, you can only have so many files open at once, and B, in some operating systems, only one program can have a file open at once. So it's good to be careful and judicious about closing your files when you've finished dealing with them. And that's what this with statement handles for us automatically. So with the file being open, we can do something to it. And the most basic thing you can do to a file, as I was alluding to before, is loop over it. So we can write for line in f, print line. We then run our script, what's it called, file.py, and it's printed out, hello, this is a file, almost exactly as we saw there. The thing that's different between the two is that here we have no blank lines, but here we've ended up with blank lines after every single time it's printed. The way to fix that, or the reason that's happening, is because every line in a file has the word HELLO, and then it actually has an invisible character at the end of every line called a new line or a carriage return, which tells it to go move on to the next line. Now that's fine, except that the print statement also always prints something and then does a new line for the next time. So we're getting a new line being printed from the file itself and another new line coming from the print statement. So we end up with two new lines after every thing that we print. To fix that, there's a few ways of doing it. The easiest way is to tell the print statement not to print its own new line. So you can do that by passing a second argument to print, the end argument, and just give it an empty string. By default, end is /n, which means print a new line. If we tell it to do nothing after printing each line, it will then print our file correctly. I'm getting something funny happening there, so I am going to do, ignore me for a second. There we go. So we say, hello, this is, and then we say a file at the end. So it's printed it. It hasn't printed a new line after a file, and then it's printed my prompt straight away afterwards. So that looks a bit messy. So let's see if there's another way we can do this. So maybe instead of suppressing the new line that's coming from the print statement, we instead suppress the new line that's coming from the file. So the way we can do that is we can take line, and we can assign it to be line, but there's a method you can call on all strings called strip. And what strip does is remove any spaces or new lines from the beginning and the end of the line. That will therefore get rid of the new lines that come from the file and leave us only with those coming from our script here. And that means we can move back to here and we can run python file.py now after saving this one. And now it does the correct thing. So what we've done there, we've called the strip method on each line of our file, which has got rid of the extra new lines that are kind of hanging around. So have a go at doing that yourself, reading in a file. Doesn't matter what file you put here, as long as it's in the same directory as everything else. And make sure you're happy being able to read it in, stripping the new lines that come with the file, and then printing out each line. I'll just cover now the last thing I want to talk about in files, since we've only got a few minutes left of the session. And that is how files deal with data types. So I'm going to change my data.txt down here to have some numbers in. 42, 9013. If we now run this again, we get those numbers printed out. Now we know that we're looping over numbers. We want to be able to do something like print line times 2. Maybe we want to double each of these numbers to get 62, 18,000 and 26. So if we run this now, see what happens. We get something strange. Instead of doubling the numbers to be 84, it's doubled the string. That's very strange. The reason it's doing that is because it's reading everything from this data file as if it is text, even if it is a number. If we know that everything in here is a number, then what we need to do is, once we've stripped it, to also convert it to a number by using, for example, the integer function. This is going to take what was line with new lines, strip off the new lines so it's just the digits, then convert it to be an actual integer, so that then we can do mathematical operations on it. This is like the difference between 2 in quotes and 2 by itself. So now when we run this, it does the correct thing. So a question there from Salim about art of knowing all the things that you need to do. As Gareth says, it just comes with practice. The more you do it, the more you learn stuff. I've been doing Python for 10 years or something now, so this stuff just becomes second nature the more you do this stuff. You shouldn't expect to be an expert at Python after a 3-hour session one afternoon. It takes time. But there's lots of people learning with you, and there's lots of people who can help. So that was the last thing in the file section. The very last summary section here has on it a big, difficult exercise, which I'm leaving as a homework exercise for you if you'd like to carry on with this after the session. With that, I'm pretty much going to wrap up. Thank you very much for attending, and I'll hopefully see you all soon. Welcome to this afternoon's course on Intermediate Python. This is a follow-on from our beginning Python course, so this will be assuming knowledge about the basics of Python, so it will be assuming you know how to make loops and dictionaries and lists and things like that. We'll be working through some slightly more intermediate material as a follow-on from that course. Now the first page of these notes here go through setting up Jupyter Lab. In the landing page there was a link to some videos, which hopefully you've had time to go through to make sure everything's all set up. Otherwise, if you've been to our beginning Python courses, then you should all be ready to go anyway. But I'm going to go through that just in front of the room now to make sure everyone's up to speed, give everyone a minute to catch up, and then we'll launch into the actual material. So the first page of the course notes here are mostly going through getting Jupyter Lab set up. So I'm going to scroll down as far as the setup, and then there'll be a little bit of demonstration. So I've switched tabs now to Jupyter Lab. This was launched through Anaconda, and I've set it up in the same way as I showed in that video. So I've got a text editor on the left-hand side, in which I've already written a short Python script. Hopefully everyone here is comfortable with that level of Python at the very least. On the right-hand side, I have a terminal. In that terminal, I can run, for example, Python, and then space, and then the name of the script, which in this case is script.py. Press enter, and it runs it and prints out what the script does. So throughout the course today, whenever we're doing exercises, I'll be asking you to do the exercises in a text editor and run them in the terminal. That's how you're going to be working on the exercises today. But in the course today, we're introducing a potentially new tool called the Python console, which I've opened up in a second tab on the right-hand side as well. So if I click on the Python console, this is where we can write and run Python code interactively. It works very similarly to a Jupyter Notebook, if you've used one of those, but we can write in here at the bottom, print, and then put something in the string, hello. I then run the cell with a Shift Enter. It prints the code and prints the response. So when going through the examples in the session today, I'll mostly be working in the Python console here because it lets me quickly iterate, but I might be using both modes at various times. So I'm just going to give you a minute now to make sure that you can A, write a Python script and run that Python script in the terminal, and B, that you can load a console and run some Python code in there as well. So as to your question, David, when you're writing code in the console, when you want to run it, you have to hold down Shift and press Enter. It might also be that Control Enter works. No, Control Enter doesn't work. So you have to hold down Shift and then press Enter, and that should run that bit of code. It looks like most people have managed to got things working now. So I'm going to just do a little bit about how the console works. So I imagine that most of you haven't come across the console before, so I'm just going to show you some of the features that it provides, which I think are quite useful. So I'm going to start off by making a list with some animals in it. So cat and dog. Normal Python list, something we've all seen before. Again, I run that with Shift Enter. So L is now a list type. So if I want to do something to this list, we learned about in the beginning Python course that we can call list.append on lists to add stuff to the end of them. So if we do L dot, but if we pretend now that we don't know what functions are available on the list, if you press the tab key just once, just press the tab key on the keyboard, then you get popping up a list of all the functions that can be completed. So you see there's the append function, that is the one that we want to do in this context, to add something to the end, as well as clear, copy, count, etc., etc. This works with more than just lists. This will work with any data type in Python. So you can always use this as a quick way of finding out what you can do with a particular piece of information. In our case, we want the append function, so either click on it or press enter. Then let's pretend that we don't know how to use the append function. We don't know what arguments it takes, and we don't know necessarily exactly what it does to the list. The Python console provides a way of finding help directly inside the console without having to go away and Google. And to do that, if you follow the name of the thing you want to find out about with a question mark, and then run that cell, and I run that cell with Shift Enter, you'll see it prints out directly in line a bit of information and context about what that function does. It does use some somewhat technical jargon, and for example, it tells you what the append function does by using the word append, which is a classic mistake. But it tells you that it's a function which takes one argument. The slash there's a behind the scenes thing, which means doesn't take any more arguments. But it tells us that whatever object we pass in, it appends that object to the end of the list. And that's a useful thing to know exactly what it does. It adds it to the end of the list, rather than the beginning or somewhere in the middle. That means we can go ahead and use it. So if you press the up key on the keyboard, we can then, that brings up the previously run command. You can keep on pressing up and you can cycle through. Up and down cycles through the recently run commands. Delete the question mark, call it like a function, and pass in something like horse. If we now run that with Shift Enter, the list has been affected, and it's hopefully added horse to the end. If we want to have a look at what is inside the list now, of course we can write print L, as we've seen previously, and we can do with normal Python. But if you just want to have a quick inspect of what an object looks like, you can just type the name of the variable, nothing else, and then run the cell with Shift Enter, and it will display on the screen the contents of that variable. So it will show us what's inside it. So if you have a little go at that yourself now, using the question mark, making sure you can display variable names just by writing the name of the variable directly, and see if you can get tab completion working. So we'll move on to the next section of the notes. I'm going to switch back over to the notes. At the bottom of every page, there is a next button. If we click on that, we end up on the next chapter. But let's go through string formatting and see what Python can do to help us. So if we go over to the console here, and let's have a look at some features. So these are features which were added in relatively recent versions of Python. There's always been ways of telling Python exactly how you want your strings to be formatted, and including variables in your strings as well. But they've added several over the years, and so I'm going to be showing you today the most up-to-date and most recent way of doing it. But first we're going to start with plain old print functions. So let's make a variable, something called mynum, and let's make it the number 42. We can, of course, print 42, and that shows up correctly. It does the number 42. No, sorry, I meant to say we can print mynum, and we run that, and it prints 42. So it's accessing the variable as we expect. We can also, with print functions, put in multiple arguments. So we can say something like mynum is, and as a second argument, pass in the variable. And that prints out the first argument you pass in, automatically puts in a space, and then prints out the second argument you put in. So this works perfectly well. There's nothing wrong with doing Python coding this way. The potential issues are that it's automatically put the space in, and so maybe you don't want it to put the space in. You want to format things a little bit more neatly. And the second thing is, if you get lots of variables and lots of things going on, this can end up being quite a long string, and it's hard to see by reading the code what your output is going to look like. And so Python introduced a way of including your variables directly inside the strings, so you can see how it's going to be displayed at the end without having to construct it out of separate pieces. So to do that, we use a print function, and we write a string as we ever did. But to enable this special mode, you have to write an F just before the opening quotes. So you write an F and then the pair of quotes, and then inside the quotes we can use the special mode. So we write mynum is, but then instead of doing a comma and then passing a second argument, we can, directly inside this string, use curly brackets. Now previously we've seen that curly brackets are used for making dictionaries. This is a completely different use of curly brackets. It's a common problem in programming that there's only so many different types of brackets that they do end up being used for different purposes. But inside those curly brackets, we can just directly write the name of the variable that we want to use. So we just write my_num inside those curly brackets, and when we run that, it's going to write this and the space, and it sees the curly brackets and it's going to replace those with the value of the variable that's inside them. So run that with Shift-Enter, and we get the same thing printed out. But here we've constructed one string which represents what we want the final product to look like, but we put placeholders in for where we want our variables to be replaced. You can do more complicated things, so we can write answer equals 42 and pi equals 3.14159 probably. Two variables there. And I can then print them out in an F string, all in one F string. So I write print, open closing quotes, again putting the F in front of the string. And inside here we can write the answer is curly brackets answer, the name of the variable. And then outside again, and pi is curly brackets, the name of the variable. And so it's going to replace this with the variable answer, this with the variable pi, and we'll print out the answer is 42 and pi is 3.14159. You can put more complicated things inside the curly brackets. You don't have to just put a plain variable name. So I'm just going to copy and paste a dictionary in here. So here we have a dictionary which has one key, which is answer, and a value 42, and one key, which is pi, and the value is 3 point whatever. If we want to print that using an F string, we can do our F quote quote thing again, and we can copy our thing from before. But this time inside the curly brackets, we want to get the value out of the dictionary. So the dictionary is called myDict. We use square brackets, and then we ask for the key from the dictionary. And we do the same thing here. myDict, square brackets to get the key, and we ask for the string pi. You'll notice here that I've used single quotes to get the string for the keys, to get the keys from the dictionary, and that's because I've used double quotes for the outside. So you have to make sure you don't use a double quote if you've made your overall string using double quotes. Otherwise, it's going to think you're closing the string and it will get confused. But when we run this, we see we get the same thing printed out. So just spend a minute or so having a go with that, and then I'm going to set you the first exercise to make sure that the first exercise goes smoothly. And that's because we're going to use the first exercise throughout the course today, build up on it slowly, so we want to make sure that everyone's set in the first place. But first, have a go at doing this F string formatting and make sure that it's working for you. So if you go to the bottom of the string formatting chapter, and I'll do the same on my screen, you'll see a big yellow box with a big long looking exercise in it. So inside here there's a big chunk of code which we are going to be working on and improving as we're going through the course today. We're going to be using it as the primary bit of code to do the exercises on, to learn and play around with the techniques that we're learning about. Luckily, this first exercise is nothing more than take this bit of code and run it. So I'm going to do the same thing as you will do. I'm going to copy this code. I'm going to move over my text editor. I'm going to make a new file, a new text file, put it over here, and I can close scripts.py. I'm going to paste all that code into that text file. I'm then going to rename it to encode.py. Because what this is doing, it is going to take a string and it's going to encode it into Morse code. Now the layout on the screen looks a little bit funky because of the line wrapping. But this up here is a dictionary which tells us for each English letter how to convert it to Morse code. So the first exercise is to take this code, paste it into a file, call it encode.py, and to then, in the terminal, not in the console, but in the terminal, to run it using Python, or if you've been told to, Python 3, encode.py. And you should get printed out incoming message, SOS, etc., and then Morse encoded dots and dashes. So take a minute now to do that same thing. Copy that from the example in the notes, paste it into a file called encode.py, and make sure you can run it in the terminal. Once that's all there, then we can move on and start learning about the first of our new techniques for this course. I'm seeing a few questions in chat. So the first one from Bryony, your syntax error. If it's saying that F strings are an invalid syntax, then there's a chance that it's because you're running on Python 2. So if you're getting that, when you run your code in the terminal, instead of writing the word Python, run the word Python followed by a 3, then a space, and the name of the script. And that will hopefully give you something that's working. F strings were only introduced in a recent version of Python. So functions are the first in the journey that we're going to be taking today. The general theme of the workshop today is learning about how you can take your scripts that you've been writing so far and package them up, make them reusable, make it so you can share them, and make it so that it's harder to make mistakes when writing code and when people are using your code as well. That's the general journey we're taking, and functions are the first step along that route. So functions allow us to reuse code. That's their primary purpose. One of the biggest sources of mistakes in programming is when you copy and paste some code and you make some kind of mistake when you're tweaking your pasted version, and it makes a mistake and then your code gets something wrong and it's really hard to spot. Functions are one of the ways that you can avoid that problem entirely and make it so that you can have a single unit of code which can be used in lots and lots of different contexts throughout your code base. So I am going to go back to my console over here on the right, and we're going to have a look at how we can learn about functions. So I'm going to start off with an example not using functions, and then go through the route of turning it into something which can be reused. So let's start off with writing a little bit of code which is going to add together the contents of two lists. So we make a variable A which has got some numbers in it, 1, 2, 3, and 4, and a variable b, which has got some other numbers in it, uninventively 5, 6, 7, and 8. When we run that, we've got our two variables ready to go. Then we're going to write our bit of code which is going to add those two lists together. And by add the lists together, I mean add the first two elements, i.e. add 1 and 5, put that into a new list. Then add 2 and 6 together and put that into a list, add 3 and 7, put it into the list, and then add 4 and 8. So we're going to be adding the lists together pairwise. In order to have something to put our result into, we have to start off by defining an empty list, which I am going to call C. Then we're going to write a loop which loops over A and B and adds them together and puts the result into C. So we write a for loop, and I'm going to write A element, B element. So A element will represent 1, 2, 3, and 4. B element will represent 5, 6, 7, and 8. For those two in, and I'm going to use a function called zip here, which you can pass multiple lists to, and it allows you to loop over both lists at the same time. So we pass A and B into the zip function. This is going to loop over the two lists simultaneously. The first time around the loop, it will give us the first item from each. Next time around the loop, it will give us the second item from each, and so on and so on. We then append our result into C, and we compute our result by adding together ALM plus BLM, if I can spell. We run this code here, and it's going to go ahead and do the calculation. Finally, we print C to have a look at what's inside it, and we see that C contains the correct result. We're going to be using this bit of code in a few examples today, so make sure you understand what's going on here. But with that, we're going to have a look at how we can turn this into something which is reusable. When you're writing code, whether it's a small script or something on a much larger scale, doing a large piece of scientific analysis perhaps, almost all code can effectively be broken down into three main sections. The first section is the bit where you read in your data and prepare your inputs. This is what we've simulated here by defining these two lists. The second chunk, and often the largest chunk of your script, will be the part where you do some kind of analysis to your data. Here we're simulating our data analysis by just adding together the two elements. This is where you might run some kind of simulation or a model or do some kind of numerical analysis to your data. The third section, that's present in most code bases, is then doing something with the output of that simulation. This is often something like save it to a file. It's often a very short part of your code. But thinking about your code in these three sections often helps you think about the flow of data and work out how you can construct a pipeline to analyze it in the most effective way. Because you'll often find yourself doing similar analyses each time, you'll often in 1 week be doing analysis which uses a particular function, and then later on you'll be using that same bit of functionality in a different analysis. It's useful to be able to package up the middle step into small pieces which can be reused in multiple places. And that's what functions allow us to do. So we're going to look at this middle part of our analysis here, and we're going to wrap that up into something which can be reused. And so instead of us having to use 3 lines of code every time to do that functionality, we can instead have a single line of code we run to call the function which implements it. So we start a function definition with the def keyword, which stands for define, because we are defining a function. We then give the function a name. And now this is the name we are going to use when we call the function. In the same way as we call the print function, somewhere there is a bit of code that says def print. Here we are defining an add arrays function. Then we need to tell it what arguments it should expect to receive. And we do that by using round brackets. Similar syntax to use when calling a function, but here we are just defining it. And we say that this function, when it's passed the arguments, is going to refer to them as x and y. So this function, when called, should be given 2 arguments. We then describe the body of the function. Notice that when I press enter after the colon at the end, it automatically indented. Like with for loops and if statements and so on, indented code means it's part of the thing that's above. So all of this code is part of the function. I'm then going to effectively rewrite this bit of code here inside the function. I'll use different variable names to make sure that we don't get confused. So I'll make a variable called z, which is going to be our accumulator. We write for x elem y elem in zip x y z dot append x elem plus y elem. Okay, and I made a typo there. Append. And then last time that was all we had to do because the C variable was left in the same level as everything else. So after we'd done our code, we could simply print C. This time, because we're inside a function, we've got our own little set of variables which are internal and private to that function. So in order for anything to get out of the function, to escape to the outside world, we have to explicitly return anything that we want the outside world to get access to. The thing that we want to return from this calculation is the variable z. And so to return it to the person who called the function, we use the return keyword, followed by a space, followed by the name of the variable. So the way we read this is we are defining a function called addArrays, which takes 2 arguments. Inside the function we are making a list, adding stuff to it based on some kind of calculation, and finally returning that new variable which we've just defined. If we run this cell, nothing has yet happened. We haven't executed the code inside. All we've done is define the existence of a function. But that means that we can now call this function in the same way as we do with print functions. We call it by using the name of the function that we just gave it, addArrays, and we pass it 2 arguments because that's what we defined it to want. It expects lists, and so we're going to give it the name of 2 lists, A and B. Notice that the lists in this top scope are called A and B, but inside the function they're called X and Y. That's perfectly fine. They don't have to have the same name at all, and in fact it's often better if they don't have the same name to avoid confusion. In the outside world we refer to them as A and B. The function knows them as X and Y. They're the same data, but they have different names in the different contexts. If we run this function, call it passing in A and B, and run that cell, I made a mistake. That should be append those added together, not add them as 2 arguments. Now, if we run this function, we get printed out the correctly added data. So we've got our 6, 8, 10, and 12, which is the correctly added together A and B lists. So Amy's asking, with zip, can you multiply, divide, etc. A and B? Absolutely. So if we look at our code here where we're doing our zip function, all that zip is doing is providing us with the elements from those 2 lists. So the elements of X and the elements of Y are going into these 2 variables. Here we are deciding that we want to add them together, but we could just as well replace that plus sign with a multiply or a divide or absolutely anything else you'd want to do with those 2 variables in order to process the data as you see fit. So if there's no more questions, we'll move on to the next exercise. So going to the notes at the bottom of the functions section, it's a chance for you to have a go at writing some functions for yourself. So the first exercise here is to take that code from that last section, which I'll just show on the screen, and to turn all the code from here to here into a function. So to move that section of code inside a function by defining a function, defining the arguments. In this case, it will take 1 argument, which will be the message to be translated, and then to call that function and check that it's giving you the same result. Once you've managed to do that, there is a second chunk of code which you can start by copying and pasting into a file called decode.py, and then you want to do the same thing to that chunk of code. Copy everything from the empty list creation to the join and put that into a function as well. In the first exercise of the 2, your function should be called encode, And the second exercise, your function should be called decode. I'm going to give you a few minutes to do this. And if at any point you want a bit of help, either ask in the chat, but also note that every exercise has an answer link afterwards. So do feel free to have a look at the answer to see if you can learn anything from it, or if you want a little bit of clarification. Lucas is asking whether it matters where you define the function. For example, in MATLAB, they have to be defined at the end of a script. In Python, you can define a function anywhere at all. As long as you've defined it before you call it, everything's going to work out absolutely fine. There's a general convention to define your functions at the top, but as long as they're defined before they're called, it will work just fine. And Luca is asking, when you define a function, does it remain in Python when you run it another time? No, a function defined will only remain as long as that script is being run. We'll see in the next section how you can write functions and have them used in multiple scripts, so you're probably predicting the future a little bit there. But on the whole, you define a function, it exists in that script, and you can use it for the rest of that one script. I'm going to go through turning encode.py into a function on the screen now in front of everyone. So whether you finish this section or whether you're still working on it, if you want to watch along to see how I'm doing it, feel free. Otherwise, if you're still working on the exercises and you just want to concentrate on that, feel free to carry on for a little bit doing that. So if we look at encode.py, the bits of code that we want to turn into something reproducible are the bits that actually do the conversion. These lines at the top of the file are our data reading in. They're setting the initial inputs to the whole thing. Both some data that's used for the conversion, as well as the message that we want to convert. These lines of code here are the bit that's actually doing the conversion. They start by making a list that we're accumulating into. They loop over the message and convert each letter in turn into the Morse code equivalent. And finally, once all of those converted letters have been put into the Morse list, we join together all of those Morse letters using spaces and put it into this variable Morse_message. So this is the section of code that we want to turn into something reproducible. This is the thing that we might want to call in different contexts. We don't always want to only call it on this particular message. We might want to call it on other messages. So we want to turn it into something reusable. We start off by defining a function. Define encode. Choosing a name for a function can be a little bit tricky sometimes. The main bit of advice I would give you is keep it short and use something which is generally an action or a verb. When you call a function, you want it to perform some kind of action, and so you should name your function in a verb sense. So this function is going to encode something. It's going to take an argument. The argument is going to be called message, and we end it with a colon. All of the code inside, we then want to indent, because that is all now part of that function. At the end, what we need to do is return Morse message. So the input comes in here, gets looped over, and then the output is put into Morse. We convert Morse into Morse message using the join, and then we return our final output. Now that we have our function, we still need to call the function. If I ran this code now, we would get an error saying, I don't know what Morse message is. So we need to make sure we call the function. I'm going to scroll down a little bit. And we call the function by using the name of it in code, call it like a function, and pass in the argument as message. The result of that function, which is what's returned here, needs to be put into a variable. And so let's call that Morse message equals. We can now save that and run it, and we get exactly the same output that we got before. The one thing I'd like to point out, which I alluded to before with our A's and B's and X's and Y's, is that this variable here is called message, but we're also calling the variable inside our function message. That's just because that's how the code looked before we functionified it, but there's no reason they have to have the same name. To make that clear, I'm going to change our internal variable names inside our function into something else. So I'm going to just call that, I'm going to call this M, and I'm going to call this M, So the message that we want to convert is called m, and that's the variable name we pass to the function. Inside the function, it refers to it as message, and finally returns Morse message. Also, these two variables don't have to have the same name. So to make that clear, I'm going to call our outside of the function variable Morse underscore m, and do the same thing with both of these. So outside of the function, we just have m and Morse m. Inside of the function, that's where we've got our long variable names. There's nothing implicitly wrong with using the same names outside and inside, but I wanted to show you that they don't have to be the same. And to demonstrate it, I will then run that bit of code. The process for the decode function works in exactly the same way. There's a bit of setup at the top, which is defining our variables. Then the bit that does the decode works like this. We've turned it into a function by indenting it, called it in code, finally called it, and printed it out. I imagine that some of you attending the course today might have done functions before. It's always difficult to know what the introductory level of everyone's knowledge is, but certainly by the end of the course today, we want to make sure that everyone's up to the same level with all the topics that we're covering. So I want to try and make sure we're not leaving anyone behind. So now we've got our encode and our decode files, and I'll show that Python decode.py works as well. It prints out SOS, we have hit an iceberg and need help quickly. We are ready to move on to the next section. So looking at this code so far, we've got some information that is being duplicated between these two files. So first of all, there's this letter to Morse dictionary at the top, which is in decode.py, but it's also in encode.py. So this is something which is central and core to the process that we're doing. It's some kind of static data that's being used as part of our algorithm to do the calculation that we're asking for. But there's other text or there's other code inside this file which is specific to the problem at hand. In this case, it's the message that we're translating. You can imagine this being a stand-in for the data that I want to analyze today, or the database that I'm getting data from that I'm looking at today. So there's some things in this file here which are usable in all contexts, no matter what kind of message I want to convert to or from Morse code. And there's some code inside these files which is specific to the task at hand that I'm doing today. And so the first thing to think about when you've got code like this is to start thinking about which parts of your code are today's job and which part of your code are going to be useful in the future when you're working on a similar task a week, 6 months, 5 years down the line. Think about which parts of your code are generalizable and which part of your code are specific to your job today. Once you've got in your head how various parts of your code base fall into one category or another, you can start making it so those parts of your code which are generally usable can be extracted out and put into something which can be used in multiple different scripts without having to copy and paste them. And this is how we're going to carry on our journey towards making our code more reusable and harder to make mistakes with. The first step was we've got some lines of code, and so we turn it into a function so that we have a defined interface of what goes in and what comes out. And so we no longer have to care about what's inside the function. We just call it and we expect and assume that the internal is going to work correctly. The next step along that path is to take the parts of your code which are reusable and to put them somewhere where all your scripts can find them. And that is a feature of Python called modules. And so to demonstrate it, I'm going to show you how we can do it with the add arrays example that we were playing with before. I'm going to make this a little bit bigger here. So I'm going to make a file called arrays.py. And inside that, I'm going to put that same function that I defined over there on the right-hand side. So this is a normal Python file. It is as you've written any other time. There's nothing special about it, but this is going to turn into a module as we work through this little section here. To turn a Python script into a module in Python requires no work whatsoever. We have our arrays.py, which has inside it a function. That means we can go to our console and we can write import arrays. You might have seen import used when you're working with, for example, NumPy or pandas or other third-party modules that you might have used before in Python. But this allows you to write your own modules, which you can put in functionality which you want to use in different contexts yourself. When we write import arrays, it's going to first of all look in the current directory for a file called arrays.py. And because we've just created one, it's going to find this file and it's going to import this module. We run this with Shift Enter. We can then do arrays dot, because dot is how in Python you get access to something that's inside something else. We have the arrays module, which is this whole file on the left-hand side. And from that module, we want to import the add arrays function. Now, if your tab completion is working, you should, after typing arrays dot, be able to just press tab, and it will show up there arrays.addArrays, and it's a function. We can then pass in A and B and run it, and it gives us out our answer. Now, this addArrays function is the one coming from the module arrays, which is the one that's defined over here. And that means as long as this file is in our directory, we can restart our computer, we can change and restart the console, but as long as we write import arrays, we should get access to it. If you're having any issues with this, and I'll give you a chance to have a go with this yourself in just a moment, the first thing to check is that you've saved your arrays.py file. Up here you should see a black X next to the file name in the text editor. If you see a little black circle next to the file name, make sure you've saved the file by going to File, Save, which is Control S or Command S. If you have done that, then the next thing to try in the console is if you right-click in the console and select Restart Kernel, that will clear everything out after pressing the big red Restart button. You have to scroll down sometimes, at which point we can import arrays again, define our A and B, and then we can call arrays.add arrays A, B. So if you're having issues, try right-click, restart kernel, run those lines of code again, and see if that works. I'm going to give you a minute now to have a go at that yourself. Then I'll carry on with the next little section. So Katie's getting an error, module not found error, as is Sophia. So the first thing to check there is that, as I said, when you do import arrays, it's going to look for a file called arrays.py in the current directory. So inside the box here, try running %ls and then press enter, and you should see the same list of files here printed in the console as you do on the left hand side in the file browser. If you see a different list of files, then you will have to make sure that you're in the same directory between the two places. So check that you're seeing the same list of files first, and if you're not, then let us know. Good, I'm glad that fixed your problem, Katie. It does get a bit confusing, and Jupyter Lab isn't always very good at keeping everything in sync. So that's always worth checking that you're in the right directory in all of the different places that need to be kept in sync. And Sophia, if you're not in the right directory, so for example, I'm going to put myself in the wrong directory. So on my computer, my code is sitting in home mat temp/python. I've put myself into the wrong directory. There we go, that's working. But if you want to move, then %cd space the name of the directory you want to move into, which is Python. CD stands for change directory. Run that, and then %ls should work. Canal points out that if you put in different length arrays, then the resultant array has the length of the shortest. That's a very good point, and later on in the course today we'll be learning how we can check for errors and raise errors in those situations. But to demonstrate what you're talking about for everyone else, if I make A and B different lengths and then run the function, we see that 4 never gets added to anything. Now there's two reasons for why that happens. Firstly is that there's no definition of what 4 added to nothing would be, and so it makes sense that it's not able to guess it. But the real root cause for it is that the zip function only loops over the arguments that passed in as long as they all have elements left. As soon as one of the arguments passed to zip runs out, the whole thing stops. That's something to be aware of when using zip. Bryony, you're seeing name error, name arrays is not defined. Make sure that you have run import arrays before you try and call the function. So you have to import arrays. You have to do that every time you restart the console, every time you do a new script, in order to make sure that arrays has a folder called my code. You could run something like my code.arrays, and it would look inside that folder for that module. Otherwise, when you've got much larger collections of code, there are places you can put them centrally on your computer where it will always be able to find them regardless of which directory you're in. The next thing I want you to do is the exercise at the bottom of the modules page. So in this exercise, we're going to take the code from our encode.py and our decode.py, and we're going to extract the common core elements and move them into a file called morse.py. Then we're going to edit our encode and decode to import Morse and call the functions that are defined inside the Morse module. You can test it in the Python console if you want to, but if you do, you will have to do the right-click restart kernel trick. Otherwise, it's not going to import any changes that you make to your modules. But spend some time on that. Make sure you're able to convert your Morse code stuff into one module called Morse, and then import it in the other two files. I'll go through the answer to that exercise now with you all, how we can turn our Morse code functions into modules. So I'm going to close arrays.py. I'm going to make a new file over here. And I'm going to call this file, rename morse.py. So encode and decode are going to represent our tasks that we want to do today. We're going to pretend that we're a Morse code operator. We've received a message and we want to turn it into Morse code. And this script here should just do the task at hand. It should define an English message and then it should work out what the Morse code message is. Likewise, decode.py is just going to define a Morse code message. It's then going to call the decode function to get back the English message. All of the stuff that does the conversions, we're going to move into morse.py. The first thing we want to move in is our two functions. So we take decode, I'm going to cut it with Control X and paste it into morse.py. And I'm going to do the same thing with encode. And paste it into morse.py. So we've got our two functions in here. But if you look at the encode function, for example, it's taking in one argument, which this function is going to refer to as message. So inside this function, using message as a variable name is valid. We can access that. We define the Morse variable. We loop through message to make a new variable called letter. This is all fine. This is all consistent. On line 6 here, we try and access the letter to Morse dictionary. And from the point of view of this function as it's written, it doesn't know what the letter to Morse dictionary is because it's not inside this module. And so we need to make sure we also move in any data that these functions need into the module as well. And so that is the letter to Morse dictionary, as well as this bit of code which calculates what the Morse to letter dictionary is. These 4 lines of code here invert the dictionary, turn keys into values and values into keys. So I'm going to take these 2 variable definitions here, I'm going to cut them, and I'm going to paste them into our module. I'm going to save that file, and I'm going to get rid of it out of here because we don't need it in here anymore, because it's not used anywhere in here. And you see, that has massively simplified the encode and decode files. They are just dealing with a task at hand, defining a message, decoding the message, and printing the decoded message. All of the complicated stuff is locked away inside Morse.py, which the users, encode and decode.py, don't have to care about. They don't have to understand what's inside here. They just have to trust that calling those functions is going to work correctly. We can do a quick test of this by going over to our console, doing import Morse, Morse.encode, and let's encode SOS, because I know what the answer should be. Gives us back ... .. So this function here is doing the right thing. We've got it from the Morse module, which is Morse.py, called the function, it's given us the response. In order to do the same thing to our encode and decode files, there's one other change we have to make, and that is we have to explicitly import our module that we've just created. Imports in scripts always go at the top of the file by convention. So import Morse. And now encode as a bare name doesn't have any meaning by itself. It is now inside the Morse module, and so we have to write Morse.encode. Importing a module doesn't automatically make everything inside it globally available. It keeps it inside what's called a namespace, named after the name of the module, which we access inside using the dot syntax. This means if we go to our terminal down here and we now run python encode.py, it's printing the right thing. We can make the same change to decode. Import Morse, Morse.decode. Printing out correctly. And so now still our job we're working on today's script is nice and short and to the point. We define our data, we process our data, and we print the result. Likewise with encode.py, define our data, do something with our data, and then print the result. The complicated stuff's locked away in the module, Morse.py, and once we've written it and it works, we don't have to worry about it again. We can just import it and use it. We saw before how moving our code into functions allowed us to define the interface that they had. We would say this function should have these inputs and it should have these outputs. We also then saw how moving them into modules allows us to reuse those chunks of code in different contexts, in one file or in another or in the console. The last thing I wanted to show about what modules and functions provide for us is the ease with which we can test that our code is working how we expect. If I make a new file up here, I'm going to make a text file called test_morse.py. I've got a module called morse.py, and alongside that I'm going to make a second file called test_morse.py. So it's the same name, just with test in front. This is a convention I like using for every module that I write, to write a file alongside it with the same name but with test underscore at the beginning, in which I put a little bit of code which I can run to check that the module is doing what I expect. So in order for that to work, we have to start by importing Morse. And because our code that we've written is an encoder and decoder, that allows us to test what's called a round trip. We encode a string, decode it again, and check that we get back what we started with. So let's make a message, hello everyone. We then make a new variable code, which is created by doing morse.encode message. I then take the result of that and pass it to Morse.decode straight away without doing anything to it, and assign that to decoded. The last thing I do is then print out, checking that message is the same thing as decoded. If message, which is our starting thing, once it's been encoded and decoded, is the same as the result, then we know everything's working well. And so I can run this script anytime I like with Python test morse.py, and as long as it prints out true, I know that everything's working. And that allows me to go to my morse.py, change stuff around, fix bugs, try and re-implement it in a different way. And as long as my test is returning true, I have decent confidence that the code is still working and that I haven't broken anything. This is something I highly recommend getting the habit of doing. This is the first step towards testing your code, but there are much more flexible, powerful, and useful techniques that you can use, and we cover those in our other course, Best Practices in Software Engineering. So do check out that course if you're interested in seeing how you can do more with testing. But for now, in this course today, this gets us most of the way there towards checking that our code is working how we expect. We're now going to move on to the largest chunk of the course today, if I go to the notes, and that is classes and objects. Now, classes and objects are something that a lot of people struggle with when they first start learning Python. It does take a bit of a conceptual shift as you're going through, but I'm hoping that I can take you on the journey today to show you how they can be useful and how you can use them in your own code. They fit in the same kind of story that we've been telling so far. We started with functions, which allow us to package up chunks of functionality and give that a name and make it so we can reuse it in different places. We then packaged up those functions and put them into modules, which allowed us to use that function in different scripts or in the console, however we saw fit. The next step along that journey is to learn how we can package up not just bits of functionality, but combine together data and functionality all into one blob, which we can reuse in whatever context we see fit. And the way that Python and most programming languages provide that is using a technique or a feature called classes. Through the example here, we're going to be writing some code which represents a dog. And so I'm going to go ahead and start writing some code. I'm going to do it in the console because we're going to be interacting with it. I'm going to restart the kernel just to clear everything out. And I'm going to clear the console cells just so that it's a nice clean slate. So let's make a variable called our dog. Now, the dogs that we're representing inside this code here are going to have a couple of attributes to them. And of the functionality that we've learnt so far, either this course or previous courses, the obvious thing that we'd reach for would be a dictionary, a thing that we can use to bundle together a bunch of disparate pieces of information. So let's go ahead and make a dictionary. The key is going to be name, and I'm going to get some audience participation here and ask in the chat if anyone has an idea of what we should call our dog. I'll go with Bruno. Bruno. The other bit of information we're going to store about our dog is its colour. Now, what colour is Bruno? I guess brown would be the obvious answer, but anyone got any other ideas? Yeah, let's go with brown. That's fine. And I'll do lowercase b. So, this is a dictionary which defines our dog. Its name is Bruno, and it's a brown dog. Now, this is a perfectly reasonable way to represent data. As you're developing code with Python, you're bound to very often reach for dictionaries as your way of bundling together disparate pieces of information which are related in some way, and where you want them to have names which you can assign and use to relate to different parts of that object. Because once you've got our dog, we can obviously do something like our dog, square brackets, name, and it prints out Bruno. So we can get the data back out again. Let's imagine, however, that we've got a function, def, called describe, which is going to read in this dictionary and print out a message which summarises the core essence of this dog. So it takes one argument, which we're going to call dog, And inside the function, all it's going to do is return a string. In fact, it's actually going to return an F string, as we saw before, which says dog, no, I need the curly brackets, name is dog colour. So it's going to print the name of the dog, the word is, and then the colour of the dog, depending on the argument that we pass in. We've now got our function defined and usable, so we can now call it describe our dog. Bruno's brown. Good. That's all working fine. The issue comes about when you realise that this function here is making assumptions about the type of data that's passed in. A cursory glance of this, or a comment describing this function, might say this function describe accepts a dictionary describing the dog, and it will print out information about the dog. That's a one-sentence summary of what this function does. But actually it's more than that. It requires that the dictionary has the key name, and it requires that it has the key colour. If you pass in a dictionary which doesn't have one of those two, then it's not going to work. It's going to raise an error of some kind. And so when we're describing how this function works, we would have to tell any users of the function, you have to pass in a dictionary which describes a dog, and that dictionary must have the keys name and colour. And if they make a mistake with that, they're going to get errors, and they're not necessarily going to understand why. One of the important things that you can do as you're developing code is make it so that any functions you write have a well-defined interface, which makes it hard for people to use them wrong. If you write a bit of code which people easily misuse, then it's not going to get very widely shared and people aren't going to want to use it. They're going to want rigid rules which allow them to avoid mistakes as much as possible. And so the main way that we can take something which is a dictionary and create some kind of data type which has a rigidly defined set of parameters or attributes on it is using a class. At its core, a class is a data type which has a strict list of parameters which must always be there, and you can rely on them being there. So let's see how we can take our definition of a dog and turn it into a class. Like with functions, which we start by writing def, we define a class using the class keyword. We then give the class a name. The convention in Python with classes is that you give the name of the class a capital letter at the beginning, as opposed to variable names, which use lowercase and underscores. This helps someone reading your code to easily see what are classes and what are variable names. We then follow that with a colon, and then we are writing the code inside the class in much the same way as we do with functions or if statements or for loops or anything else. The main things that sit inside classes are functions. And so we're going to define a function now which is going to describe what a dog looks like. So we do that with def. Now the special function that we have to create to define what a class looks like is called __init. There are 2 underscores before and 2 underscores afterwards. This is a special function which is called in order to initialize the class. It's going to set it all up so that we know it has the parameters and the attributes that we expect. It takes arguments because it's a function. All class functions always have to take an argument called self at the beginning of their list, followed by any arguments that we want it to accept, which in our case are going to be name and colour. And it's a function, so we end it with a colon. I'll come back to explain how init and self relate to each other in a little while, but for now we're going to make this dog class, use it, and see how it works. Inside this function, we are going to set some variables, and we are going to set those variables. We're not going to return them at the end, but we are instead going to attach them to this variable self. This variable self is representing the dog in question at the moment, the dog that we care about, the dog that we are currently initializing. And so if you do self.name, we are talking about the variable name that's attached to the object self. We assign that the argument that was passed in, name. We do the same thing with color, self.color equals color. At this point, we have finished defining and describing our class. That's all you need for a class that has two attributes on it. So we run that cell with Shift Enter, and it gives us back no error. So it's worked. That class now exists. In order to make an instance of that class, we call it like it's a function. We name the name of the class followed by brackets. The arguments that we put inside the brackets are the arguments that are going to be passed into the initialize function, not including self, because self gets handled automatically. It's the other arguments that get passed in. So we can pass in Bruno and Brown. We want to assign this to a variable, so let's call it our dog again. We run that, and that has created an instance of the class dog, which we are now calling our dog. Dog with a capital D is a class. This code here defines a class. This variable here, which was created from the class, is what's called an object or an instance. Now that we've created this thing, we can go ahead and use it. We can say our dog.name, run that, and it tells us that our dog is indeed called Bruno. So we're accessing attributes on our dog with a dot syntax followed by the name of the parameter that we care about. And that is in contrast, if I scroll up a moment, to our dictionary style where we gave the name of our variable followed by the square brackets syntax. So if you've got a dictionary, use the square bracket syntax. But because we're now inside using a class, we can use the dot syntax. We can obviously do the same thing with dot color, and we get out brown. This means we can now adapt our describe function so that instead of taking a dictionary and assuming that there's a dictionary being passed in, we can have it so that it assumes a dog object is being passed in. So here instead of instead of dog square brackets name, we do dog.name, and instead of dog square brackets color, we do square brackets color. We can now call the describe function on our dog, and it prints out Bruno is brown. So take a minute now yourself to write this code, copy it in. It's all written in the notes, so feel free to copy and paste it from there or use that as a reference. Spend a minute writing that code, running it, making sure you can make instances of your dog. You can get the attributes out again and adapt the describe function so that you can pass in a dog object using the dot syntax, get the attributes out and describe the dog, have it all work correctly. One way of thinking about a class in Python, and in fact in most programming languages, is that it can be seen as a template with which you can create objects. So the code here doesn't represent one single dog, it represents all possible dogs we might want to create. So here we created one instance of the dog class, we called it Bruno, and we called the variable name our dog, but we can create more. We can create an other dog, and there's been some great examples of dog names in chat, and let's go with Achilles. And what colour is Achilles? Achilles is blue, a very unusual colour for a dog. It's probably been mistreated. There we go. And I'll just run that our dog Bruno line again, so they're next to each other. So here we've called the dog class 2 different times. Each time we've called it, we've created a different object. And so the way that works when you're inside your class is that when we called our dog, and we call dog Bruno Brown, dog is then going to look at the dog class. Because we're calling it with the brackets, it's going to create an instance of that class, which is going to need to be initialized. And so Python will automatically call this magic function underscore underscore init, sometimes called dunder init for double underscore init. And it's going to pass in the two arguments that we passed in here as name and color. The self object here is referring to the same thing as what's going to get passed out at the end. So self here refers to the same thing as our dog. And so when we do self.name, we are effectively doing our dog.name equals, which is why our dog.color, our dog.name give the right thing. When we call this class a second time, when we did other dog, this time in the function, name and color are obviously different because we're passing in different arguments, but self is also pointing at a different object. Self this other time is pointing at the same thing as other dog. And so self is the special argument in any class function which gives you access to the object that you're currently talking about. And so because self allows us to talk about various different things about the class, we can use it both to put data into the class, we can also use it to get data out. And so now let's see how we can extend our class here by adding some functionality to it. I said at the beginning that classes combine data and functionality. So far our class is all data. It just defines some data which is held by the class. We want to give our class some functionality as well. And to that end I come back to our describe function. At the beginning I was lamenting the fact that you have to remember not only that the first describe function, if I scroll up, took a dictionary and you had to remember to pass in the word dictionary, you had to also make sure the dictionary had the name and the color attributes or keys inside it. We improved that a bit by saying that our describe function here is going to enforce that as long as you pass in a dog object, it will always have name and color, because both of those variables are always defined inside the init function. But we still have the possibility that we could pass something completely wrong to dog. We could do describe hello, and when we try and run that, of course we get an error because the describe function doesn't understand how to describe a string. It only understands if it's passed a dog object. And so what we want to do is make it so that our function can only ever be called on a dog object, and it can't be used outside of that context. And so I'm going to bring up our definition of dog again and run it so that it's on the screen. I'm going to go back up to our definition of our class, and I'm going to show you how you can take this function that's currently freestanding and move it so that it's a function inside the class. I'm going to copy the code because it's going to be only a short few steps. We move it so that it is alongside the init function. We paste this code here and make sure that it's indented so that it's at the same level as init and the internal indentation is all the same. The next thing we need to do is, like we had with the init function, the first argument was self. Here the first argument of describe is going to be self. And as self here was referring to an object of the class dog, likewise self here can refer to an object of the class dog in the same way that the dog variable in our freestanding function did. That means we can simply rename this variable to be self, rename this variable to be self, and rename this variable to be self, and that's all we have to do. We have now moved the describe function inside the class to be a class function. Class functions are sometimes also called class methods. Those two bits of terminology are somewhat interchangeable in Python. Now when we define this class, it has got two functions on it. I can make our Bruno dog again. We have to recreate our dog because it was still referring to the old version of the class. And that means that we can now do our dog dot, and instead of doing dot name or dot color, we can now do dot describe. Notice that we don't put anything in the brackets of describe, and that because in the same way as self in the init function was automatically put in there, in the describe function, likewise, it's automatically passed in, where the argument that's passed in as the first parameter to describe is taken from the thing in front of the dot. So writing our dog.describe will call this function with our dog passed in as self. And that means inside the function, self.name is doing owdog.name, and self.color is doing owdog.color when we call this function here. So that means if we run this code, it gives us back the description of our dog. And there is now no way to call this describe function on anything that's not an dog type. If we try and make a list and do l.describe, that's not going to work because the describe function isn't defined on the list type. It's only defined on the dog type, and this will give an error. So I'm going to ask you to take a moment just now and do this same exercise with your dog class. Take the describe function, move it inside the class so it becomes a class function or a class method. Redefine your dog. Of course, you can give it any name and color that you wish. And check that calling owdog.describe does the right thing and prints something out. Take a minute or so now to do that, and then we'll be moving on. Harry, you're seeing a strange output of bound method dog describe and then a whole lot of hexadecimal, and I bet I can reproduce that. So I imagine what you've done is type something like owdog.describe and then haven't passed the brackets afterwards. So if I run that, I get a very similar thing. And this points to an interesting feature of Python, which we cover in more detail in our parallel Python course, and that is functions exist as objects in their own right. If you don't put the brackets afterwards, it tells you that thing you just told me about, that's a function, or as it calls it, a method that's been bound to the class. And so if we put the brackets afterwards, it does the right thing. So far, our dog is a little bit sad, really. It has a name and a colour, but it doesn't have any functionality. It can't do anything. It's entirely static. We create it, we give it a name and a colour, and then it exists in that form, changeless for eternity, or at least until we turn off our computer. We want to have the ability to represent data inside our classes which can potentially change over time. Something which is going to represent the state at one point in your program, you call some functions and it keeps track of things, and it has a different state at another point in your program. So we're going to make a new parameter or new attribute of our class, which, unlike these two arguments here, we're taken from the argument list, you can just make static data which is attached to your class. So we can make a new variable, self.energy. This is going to represent how much energy our dog has. Now, if anyone has had a dog, you'll know that they have a lot of energy. But we're going to pretend that initially our dog is always created with an initial energy of 1 and some kind of units undefined. So this parameter here, this attribute, isn't being defined based on an argument being passed in, it's just statically defined to any new dog that's created to always have an energy of 1. So if I create that and I make our Bruno dog again, in fact, let's make a different dog because we've had some good examples in chat. We had one earlier called Corona. And I'm going to make Corona gold. So now our underscore dog dot energy is number 1. It's got an energy of 1, so we've got some information about it. So that's all very well. We can, change the energy to be 100, and then it's got an energy of 100. But it's nice to, instead of having to dive into a class directly and change its parameters, to instead have functions which do the actions which we want this class to perform and keep track of the internal state for us. So we're going to be adding some more functions to our class which allow us to exercise our dog. So the exercise function is going to reduce the amount of energy that our dog has. So we go back to our class here, and we're going to add another function, def exercise. Again, it takes the self parameter, self argument. It's very easy when you're writing functions into classes to accidentally forget the self but you'll quickly notice it when you try and use the code. And the exercise function or method is going to print out a message telling us that you take self.name for a walk. And then it's going to do self.energy. Notice that self here is the argument that's passed in, so it's going to be referring to the same thing as this. Minus equals, that's how you decrement or decrease a number by a certain amount, 1. So this function will print out something and then reduce the energy by 1. So if we make our dog Corona again, we print out the energy. Our dog dot exercise. It prints out the message. We took Corona for a walk. If we look at the energy a second time, we see the energy is now 0. If we make a second dog, to draw home the point that each dog object is an independent thing, if we make our Bruno again, other dog, other dog dot energy has not changed. So each dog has got its own internal energy attribute which it's keeping track of. So have a go at implementing the exercise function now, as well as adding in the energy parameter. Once you've done that, have a go at making a fourth function on the class called feed, which is going to feed the dog and increase the energy by 1. I have on the screen here the example of the feed function. So the feed function works exactly the same as the exercise function. It prints out a message saying that the dog eats the food, and then it does self.energy plus equals 1 to increase the energy. So if we define that class, redefine our dog, we can now do other dog dot feed, and it eats the food. We can do it again, and it eats the food again, so that if we look at other dog dot energy, the energy is now 3. So it's a dog with an infinite appetite, which will accrue an infinite amount of energy. But such is life when you're simulating things on the computer. There's some text on this chapter here, which is explaining how this stuff all works. So do have a look at this text later on. All these course notes will stay up permanently. So do have a look through the text here if there's anything you're not clear about. But have a look at the exercise at the bottom here, which is to edit the morse.py script, which is our script which is holding our library code, our functions and our static data, and to create 2 classes. One a class called English message, which has the encode function moved inside it, and another class called Morse message, which will have the decode function moved inside it. And then to change test.morse.py or make a new file called test.morse.py, which imports those 2 classes, makes a string and an English message from that string. So this is calling our first class. Calls the encode function on it to get back the encoded text string. Then to take that encoded string and to make a Morse message from it, and to call the decode function on that, and to check that we get our answer back at the end. Have a look at this exercise and see if you can create a class for the encode function called English message and a class for the decode function called Morse message. Again, there is an answer at the bottom of the section, so do feel free to have a look at that answer in case my description of the question isn't good enough, or if you want any help along the way. And likewise, feel free to post in the chat if you have any questions. I'll give you a few minutes for this one because it's a little bit trickier. As to your question there, Emma, about it not changing the energy, I'm going to show you on the exercise here what you've done. So you've written return that string in the same way as you did in the describe function. And that means as soon as the exercise function gets called, it's going to return that string and the function is going to end, which means it's never going to get to this second line here. Instead, change it so that you write print as a function so that it prints that, outputs it, and then carries on to the next line, and that should then work. Gunar's asking, what if I don't put init in a class? So in the example here, if I didn't have an init function at all, it would still work. It would mean that you can only call your function or create an object of your function without any arguments at all, which means that none of the parameters or the attributes of it which are assumed to be there will be created. You will effectively create an empty class which has no data, which only has functions. It's a perfectly valid thing to do if you want to bundle up a few of your functions under some kind of namespace. But on the whole, you usually want to have some data in your class as well as functions to act on that data. I'll go through the answer to that exercise on the screen now, so you can all see how I can convert a function and some associated data into a class which is encapsulating both of those things. The easiest place to start is with the function here, and we write class English message. This class is going to represent a normal string, an English string, which is going to have an encode function on it, which is going to return to us the Morse encoded string. We want to indent this, and we'll come back to the rest of what we do to that in a moment. We have to make an init function, and the init function, like all functions, takes self, and that is, and message. So we're going to make one class which represents a message, and that message is going to be wrapped up and saved into the class with self.message equals message. The other thing that we want to save into our class, because we want to use it inside our function, is the letter to Morse dictionary. So I'm just going to copy, in fact I'm actually going to cut it, and paste it into here, make sure everything's indented nicely, and write self.letter to Morse. So this is saying that our class is going to be initialized, or an object of our class will be initialized with an attribute message, which comes in from what's passed in as an argument to the constructor, as well as an attribute which is storing our conversion dictionary. That means in our function down here, where we are going to be converting our message, it has to take the self argument. Now message isn't going to be passed as an argument to self, and that's because we don't need to anymore, because we can access message through self as self.message. And so here, instead of writing message, we want to write self.message. And here, instead of writing letter to Morse, we want to talk about this letter to Morse up here. So we write self.letter to Morse. And I think that is all the changes we have to make. So I'm going to save that file. I did, when you weren't looking, make the same change to the Morse message class, which has got a self.message, a self.morse to letter attribute, and then the same decode function, which had the same stuff done to it. That means that we can come over to our test Morse file, which imports English message and Morse message. It's going to call the English message class and pass in a string. That is going to call this init function with message as the string, which will then be saved as self.message. It calls the message.encode function, where message is the object of that class we just created, which is going to call this function here, do the same stuff we've been doing so far, and return our message out at the end. That goes into code string. We can then stick that back into the Morse message class and do the same thing in reverse, where we call it, make a Morse message object, call code.decode, and then compare the two. So now hopefully when I run this over here, I will get out true printed. So that means we now know that everything is working. We could also do from Morse import English message, English message. We'll do our SOS again. Let's call it M. And we can do m.encode, and we get back our Morse code. This means we can't accidentally call encode on something which is a Morse code message, and vice versa. It makes sure the type is holding both the data and the things that we can do to it. No one's piping up in chat to say they're having any problems or have any questions. I will say that classes in Python and in any language are often one of the biggest increases in complexity you come across when learning the language. Hopefully I've done a good enough job of explaining how they're used, how you can construct them, and what their purpose is, but they do sometimes take a little bit of experience and practice to get the full value out of them. Kunal is asking why I wrote from Morse import English message there. So I could have written, exactly as I did before, import Morse, and then done Morse.English message, SOS. That gives us back an object of that class. But by writing from Morse import English message, I've extracted out just the one thing that I care about from the module, and so I get access to the class name just by itself without having to write Morse in front of it. So the last section that we'll cover today, actually no, before we do the last section today, a thing about naming. I did mention this earlier, but classes often have these capital letter names like Morse translator or dog. Whereas variable names and function names use this snake case. It looks like a snake because it goes on the ground and it's got sort of up and downs to it. So snake case in Python is used for variables and functions and modules, in fact. Whereas camel case, and it's so called because it's got these humps, is used for classes. If you stick to this convention, then other people reading your code are going to understand what's going on. So the last thing I'm going to cover today is on the next section of the notes, and that's handling errors. So going back to our console, let's have a look at what these dog classes can do. So let's create our dog again so we know what state it's in. And let's make a other dog equals dog Bruno Brown. So we've got our dog defined. Our dog can do things. We saw before, we can perform actions on the dog. We can call these functions, and we can do other dog dot exercise. That works fine. And we can do other dog dot exercise, and we can exercise it, and then we can do other dog dot exercise, and it keeps on walking, and it keeps on working, and everything seems like it's all working well. And that is until we ask the dog how it's doing, and we look at the energy of the dog, and we see that somehow its energy has ended up negative. Now, under very few definitions is a dog with negative energy doing very well. And this is because we've allowed our exercise function to arbitrarily keep on reducing the energy attribute by 1 every time we call it, without any checking that it has energy to go for a walk. And so let's look at what tools we have at our disposal in order to make sure this stuff is being checked as we're going through. So the main tool that we've had at our disposal so far for checking stuff is an if statement. So let's go ahead and use the tool we already know and see how far that can get us. So we only want to exercise if self.energy is greater than or equal to 1. If it's 0, then the dog can't go for a walk because it's going to end up with negative energy by the end of the walk. We are going to allow the dog's energy to get to 0. That just means it's very tired. So if the energy is greater than 1, we allow it to happen. And so if we run this code, define our dog, and make our dog, and then exercise it, we get the message printed. If we try and exercise it a second time, we see that no message gets printed. We can exercise it as many times as we want, but if we go back and check what the energy is, the energy has stopped at 0. It's never gone below 0 because we are checking as we go along that the state of the system that we're looking at is in some kind of sensible situation. Of course, it's very easy to miss that this one printed something and this one didn't. And so we really want to, when we're printing these things out, to print something else in the situation where the dog is out of energy. So let's write else, and I'll copy and paste this. The dog is tired, it doesn't want a walk. So if we now run that class and define it, make our dog, and try and exercise it, it works once because we reset the energy to 1 in our initializer. If we try and do it a second time, it tells us that it's unhappy. That's good. We've now got something printed in the good state and something being printed in the bad state. But when you're writing code which is going to be used by other people, it's still very possible to ignore this line accidentally. If, for example, we do this same line of code multiple times because we think that everything's working fine, and then we do afterwards other dog.describe, because we've seen here that we've run this 3 times, we're going to expect that the energy is going to be 3 lower than it was. Now let's look at energy. But actually, it's silently failing, and it's allowing these more exercises to carry on. It's allowing us to keep on trying to walk our dog without us being told explicitly and forcing us to make a decision to notice that it is in fact tired. And so the way that you can raise an error in Python which the person calling your function can't ignore is with a thing called exceptions. And so we can raise an exception in our code. I'm going to make this a bit bigger. By instead of just printing out this message, by writing the word, and I'll make this wider here as well, so that everything fits on the screen, the raise keyword, followed by the type of error that this is. Runtime error. In the notes here, there's a link to the documentation which lists all the different kinds of errors you can raise. In this situation, it's an error which has occurred while the program's running, and so raising a runtime error makes sense. It's up to you to decide what kind of error makes sense for your situation. So now when we exercise that code and we make our dog, and if we try and exercise it too many times, we get an error raised, a deliberate error which tells us that a runtime error was raised and the dog is tired. If we look at where the lines of code raise the error, we see that it's telling us in the exercise function on line 15, we raise the error, but that was called from these lines of code here, which are these lines of code here, and you see it's stopped on line 2. It's tried to exercise it this second time, hasn't been able to, and so these other 2 lines of code here will never ever run. It's forcing us to make the decision about how we deal with this problem. Now there's a few ways that you can deal with an error that's being raised like this, but one of the most common is using what's called a try except state. A try except block is going to try and run some code, but if an exception or error is raised, it's going to allow us to run a different bit of code to kind of deal with the error that we're seeing. So we write try, and then we put this code in here. I'm going to try and do this, except if there's a runtime error raised, in which case we are going to print something out. And see, now when we run this, it says something went wrong. So this code was attempted to be run, a runtime error was raised, and so this message gets printed out. That's good, we were able to catch the error and deal with the situation, but we've lost the information about why it failed. And so what we can do in this situation is take the error that was raised, capture it, and give it a name by writing as E. Then if we turn this into an F string, we can put E as a parameter inside the F string. So now when we run this, we get something went wrong with trying to access the dog, and then the contents of that error printed out. So printing a logging message when you've got an exception raised is a useful thing to do, but in some situations you can actually deal with the error and fix it in that situation. So for example, we have our try block still, but here inside the exception handler, this except state here, if the dog has run out of energy, we can try and feed it. And if we feed it, then we will be able to exercise it. So we've tried to do these lines. If any of them fail due to a lack of energy, then we end up in this block, at which point we can feed it and try and exercise it once more. So when we run this, we see that one of these lines failed, presumably the first, because we never saw an exercise line be printed. It's gone to this section here, where it has fed the dog, and then it's able to successfully take it for a walk without any further exceptions being raised. So for your homework after this session is to take the ideas that we had here with catching errors and raising them and apply them to the encode and decode code that we have inside our Morse code translator. If you try and translate code in Morse code which contains exclamation marks or @ signs or pound signs, anything like that, it's going to fail. So the exercise at the bottom of the handling errors chapter, I'll leave as homework for you, and it's to take this same idea of try excepts to catch the errors as they're raised and to practice applying the try except statement to them to make sure you get a sensible error message printed out. On the very last page on the notes, there's a link to our summary, which goes through what we learned today, as well as some links to the notes for some of our future courses. So do feel free to have a look at the notes for those and sign up for any of those courses if we're running them in the future. With that, I'll just say again, thank you all very much for being here today. Really great session, and I look forward to seeing, hopefully, all of you in one of our future courses. Bye-bye. Data analysis in Python. This is a continuation really only from our beginning Python course. We've tried to keep the requirements for this data analysis course as minimal as possible to make it useful to as wide a range of people at the university as possible. We don't want people to feel they have to be an expert in Python before they can start using it for making their job and life easier. So we only require a relatively small amount of Python experience. But that said, there might be some things in this course which are new to you. So as we're going through, do feel free to ask in the chat if there's a particular piece of syntax or a particular function that we're using that you're not sure how it works. Please do post a message and ask for a bit of clarification, and we'll try and help out. In order to run the session today, in the previous classes, we've been using Jupyter Lab, which we've installed through Anaconda. Jupyter Lab, we've been writing text files with our Python scripts in, and then running them in a terminal. In the session today, we're going to be using a tool called a Jupyter Notebook. Now, it's possible some of you have used a Jupyter Notebook before, so just to get a bit of a sense of the room, could people post in the chat whether they have or have never used a Jupyter Notebook before? No? Good. So lots of people who haven't used them before, so that's going to be the first thing we go through today. Those who have used it before, this first 10-15 minutes or so, feel free to follow through it as well. Otherwise, since all the material is self-guided, you can just carry on through to the next section without waiting for me to get to it, if you so wish. So the first thing to make sure you've all got is Anaconda Navigator, all started up and running. So I'm just going to give you all a minute or so, or 30 seconds or so, to start that up and have it running in the background before I carry on to actually starting the session. Okay, so hopefully you all have Anaconda Navigator started up now and running. It should look something like what I see on my screen here. You might have a slightly different list of apps, or you might have slightly different versions of things, but hopefully it's a similar kind of idea. Now, I said we were going to be using Jupyter Notebooks today. However, I don't want you to immediately click on the Jupyter Notebook launch button. If you do want to use that mode of launching Jupyter Notebooks, it's okay. It's going to work just fine. And if you feel more comfortable there, that's okay. But for the session today, we are going to use Jupyter Lab as the way to start the Jupyter Notebook server. I'm going to explain what these terms mean in a little bit. But if you go ahead on the Jupyter Lab tile, which is probably the first one, and click on the launch button, that should open up in your web browser, one that I prepared earlier, that looks something like this. So I'll just move those to the side so we can see both of them. So click on the Jupyter Lab launch, and that'll open up in your web browser something that looks like this. I'm going to go ahead and make this window here full screen and extra full screen, and the rest of the session we're going to be living inside this window here. So Jupyter Lab is a web-based, I say web-based, it runs entirely on your local computer, but it works in your web browser, even though it's entirely local. And it gives you an environment where you can run Python code, you can write Python code. One of the things it has built into it is its own Jupyter Notebook environment. So the very top icon you should see on your launcher, and if you've been to our previous sessions, you might not be seeing the same view. So just go ahead and you might, for example, have something that looks like this. Just go ahead and close all the tabs at the top. That's perfectly fine. Click on the Python 3 icon under the notebook header, and that will open up a Jupyter Notebook which should fill the whole screen. So having clicked on that Jupyter Notebook Python 3 tile, you should get something that looks something like this. Now this is called a Jupyter Notebook. I'll just give you 30 seconds or 20 seconds or so to get this started up, and again, if any issues, post in the chat. What we have here is a Jupyter Notebook. A Jupyter Notebook is a way of writing and running Python code in an interactive way. And it also provides us with a bunch of extra features which are really useful when we're doing data analysis kinds of tasks. So at the first case, what we can do is we click inside the grey area here and we can type any Python code we like. I'm going to keep it nice and simple. We can print hello. Now, if you just press enter at the end of the line, it just puts another line inside that cell. So it doesn't run the code just by pressing enter. If you want to run this cell, you either click on the plus button just above it up there, or hold down shift and press enter. I'll click the play button this time, but in the course of this session, I'll probably quite regularly be using shift enter or control enter to run the cells. So you will sometimes see me running a cell without clicking it, and that's what's happening there. If I click the play button, it runs that cell and prints hello. It also gives every cell that's been run a number, so you can keep track of which order they've been run in, because in principle it's possible to rerun cells that are further up the page after having run further cells that are further down the page. It can get confusing, and we'll try and cover that later. So I'm just going to switch over to the notes now and copy and paste a few examples from here. So one thing we can do, as I said before, is have code over multiple lines. I'll just show that by typing. So A equals 5, B equals 7, A plus B. If I do shift enter, it runs that cell and displays 12 on the screen. Notice here in this second case, I haven't had to write print A plus B. I didn't need to do this, because the way that Jupyter Notebooks work is whatever the last thing in a cell is will be displayed onto the screen. So here, because A and B has the value 12, it's displayed 12 underneath the cell as the output for that cell. And you see the output and the input have got corresponding numbers. As well as being able to run Python code as we have done in the script so far, it also gives us an extra ability to, didn't mean to make that small, there we go. An extra ability to display output from commands in a slightly more visually pleasing way. Now, don't worry about what this bit of code here does. We're going to be discovering how these things work throughout the session today. I'm just going to make my font a bit bigger. We're going to be discovering how this works throughout the session today. But if you run this, it's going to print something that looks like a nicely presented table of numbers where you hover over it and the lines get highlighted, which is useful when you have larger tables of data. The thing that's really useful, however, is the ability to display plots. So here, again, I'm just copying and pasting this in. We'll be discovering how these things work throughout the course. If I run this cell with shift enter, we get a plot coming up in line. So if you use something like Mathematica, or I think MATLAB can do this, and R notebooks do this too, it lets you run code and get the output from that code right there, and then you can carry on further underneath and, you know, print whatever you want, and you've got the code in line at the point where you ask the figure to be shown. The final thing that it allows you to do is, as well as having cells which contain code, at the top of the window there's a drop-down menu that says code at the moment, and with this cell selected, if if I change that to say Markdown, if I click on the Markdown button on the drop-down menu, you see the square brackets at the beginning have disappeared, and now this won't accept Python code and run Python code. It will instead accept Markdown. Now, Markdown is a way of applying formatting and design to plain text. So you can start headers by doing a hash key, and you can write header. And then if we run that cell, you see it turns the word header into a big word header. You can then double click on it to edit it. You can write bold text and italics, or I could if I could spell correctly. And you see it formats it with bold and italics. And so what this allows you to do is to interlace with your code blocks of text which describe what your code is doing. And the real powerful thing about this is it gives you the ability to write a whole